Hello, and welcome to a quiet journey. We live our lives surrounded by things, by people, by noise, by light. Even on the clearest night, the sky is a blanket of distant suns, a constant reminder that we're part of a busy, crowded cosmos. But what if that's only a small part of the story? What if the universe is defined not by what's in it, but by what's not? Welcome to the Science for Deep Sleep. If this kind of calm exploration into the universe helps you unwind, consider liking the video and subscribing to the channel. And wherever you are right now, whether near an ocean, a forest, a city, or somewhere quiet in between, feel free to share where you're watching or listening from. Tonight, we aren't traveling to a brilliant nebula or a bustling galaxy. There will be no blazing stars or populated worlds on our itinerary. Instead, we're going to drift into one of the most profound, peaceful, and unsettling places in the entire known universe. A place of such impossible scale and emptiness that it forces us to reconsider what space truly is. It's been nicknamed the Great Nothing. This is a journey into an absence, an odyssey into an immense, quiet, and beautiful darkness that holds secrets to the very structure of our reality. So, find a comfortable position. Allow your body to feel heavy and relaxed. Take a slow, deep breath, and just let it go. We're about to begin our voyage. Let your mind drift as we travel together to the largest empty place in the universe, the Boötes Void. Right now, as you settle in, you're moving. You're on a planet, spinning at 1,000 miles an hour, while orbiting a star at 67,000 miles an hour. That star, our Sun, is hurtling through the Milky Way galaxy at nearly 500,000 miles an hour. And our entire galaxy is itself falling through the universe. We are in constant, furious motion. And yet, tonight, we're going to seek stillness. We're going to a place where the universe itself seems to have paused, a region so profoundly empty that for hundreds of millions of light years, there is almost nothing at all. It's a silence on a cosmic scale, a place that feels like it shouldn't exist, yet it dominates a vast portion of our sky. Let the noise of the world fade. Let the busyness of the day fall away. Our journey has already begun. The journey begins, leaving the familiar. Our journey starts from a familiar blue marble, suspended in the black. Imagine our perspective pulling away from Earth. The continents, at first so defined, blur into patterns of green, brown, and white. The curve of our planet becomes a sharp line against the infinite backdrop. We drift past the moon, a silent, pockmarked companion, its desolate beauty just a tiny prelude to the kind of emptiness we seek. Our imaginary vessel accelerates. We're moving now at speeds impossible to comprehend, slipping past the orbits of Mars, Jupiter, and Saturn. The great planets, which have governed human wonder for all of history, shrink behind us into bright, star-like points, their majesty swallowed by the growing distance. The sun itself, the giver of all life on Earth, becomes just another star, albeit a bright one, in a sea of countless others. Soon, it too is indistinguishable from the rest. The comforting layout of our solar system is gone, collapsed into a single point of origin that is fast receding. We're now in interstellar space, the space between the stars of our own galaxy. And already, the view has changed. The sky is no longer a canopy of familiar constellations, but a thick, unbroken river of light. We are looking at the Milky Way from inside one of its spiral arms. Hundreds of billions of stars, so many that they merge into a luminous, cloudy band, surround us. It's beautiful, chaotic, and bright. But this isn't our destination. We must go further. Our vessel pushes outward, perpendicular to the galactic plane. The river of stars thins. The thick, glowing band of the Milky Way resolves itself into a shape. From this vantage point, a few 100,000 light years away, we can see our home for what it is, a colossal, spinning disk of stars, gas, and dust. A beautiful, self-contained island of light. It is magnificent. It's our entire world, the home of every person who has ever lived, every story ever told, every star we've ever wished upon. And now, we're leaving it behind. As we continue to speed away, our galaxy shrinks. It becomes a bright spiral in the darkness, then a small, fuzzy patch of light, and then, it too becomes just another galaxy among many. We are now in intergalactic space, the space between the galaxies. And here, a new kind of emptiness begins to make itself known. The sky is no longer filled with the overwhelming light of the Milky Way. Instead, the universe reveals itself as a dark expanse, punctuated by the faint, lonely lights of distant galaxies. Each point of light is an island like our own, containing billions or even trillions of stars. They're separated by millions of light years of cold, dark space. This is the beginning of true cosmic loneliness. If our own galaxy were the size of a dinner plate, the next nearest major galaxy, Andromeda, would be another dinner plate 25 feet away. In between is a vast, dark, and mostly empty room. The universe, we're beginning to see, is mostly made of these empty rooms. The light, the matter, the life, it all exists on these tiny, scattered plates. But even this profound emptiness isn't our final destination. We're heading for a place that makes this intergalactic void seem crowded by comparison. A place where the dinner plates are not just feet apart, but miles. A place where the universe forgot to put the galaxies. We're still hundreds of millions of light years from our destination, and the journey itself is reshaping our understanding of what the universe is made of. The cosmic web. The universe's grand design. To understand where we're going, we first need to understand the map of the universe. From our vantage point, floating in the space between galaxies, we can begin to see the grand pattern. The galaxies aren't scattered randomly like dust motes in a sunbeam. They're organized. They are arranged in a magnificent, luminous structure that stretches across the entire cosmos. Scientists have a name for it, the cosmic web. Imagine the universe as a gigantic, dark sponge. The material of the sponge itself, the interconnected fibers and walls, is where all the matter has gathered. These are called filaments. Along these shimmering, impossibly long threads, galaxies are strung like pearls on a necklace. Where the filaments cross, the light is brightest. Here, galaxies are drawn together by gravity into massive groups called clusters, and even larger superclusters. These are the great cities of the universe, bustling with light and energy. Our own Milky Way is located in a relatively quiet suburb of one of these, the Virgo supercluster. But what about the rest of the sponge? What about the vast, dark holes in between the fibers? These are the cosmic voids, and they are the main feature of the universe. The brilliant filaments and dazzling clusters are just decorative tracery on a structure that is defined by its emptiness. About 80% of the entire universe is made up of these voids. We live in a cosmos that is mostly empty space, with all the glittering galaxies confined to a delicate, foam-like web stretched across the nothingness. This incredible structure wasn't always here. To understand where it came from, we have to cast our minds back to the very beginning of time. In the first moments after the Big Bang, the universe was an incredibly hot, dense, and almost perfectly uniform soup of matter and energy. The key word there is almost. Because of random quantum fluctuations, tiny, unpredictable ripples in energy, some regions of this primordial soup were just a tiny bit denser than others. Think of it like a perfectly smooth surface of water, where tiny, fleeting ripples appear and disappear at random. In the newborn universe, these ripples were in the very fabric of reality itself. As the universe began to expand with incredible speed, these tiny fluctuations were stretched to enormous scales. A ripple that was once smaller than an atom was suddenly millions of light years across. And now, gravity began to do its work. The regions that were slightly denser, even by the tiniest fraction, had slightly more gravity. Over millions and billions of years, this tiny advantage grew. The denser regions began to pull in matter from the surrounding, less dense areas. It was a slow, patient, cosmic sorting process. Matter flowed from the emptier regions toward the denser ones. The dense regions, fed by this cosmic migration, collapsed under their own gravity to form the first stars and galaxies. These galaxies then pulled on each other, gathering into the clusters and superclusters we see today. They arranged themselves along the lines of those original, stretched-out ripples, forming the shimmering filaments of the cosmic web. And the voids? The voids are what was left behind. They are the vast regions of space that were, by pure chance, born with slightly less matter. As gravity pulled all the available material toward the filaments, these areas were emptied out, becoming the great cosmic bubbles we now see. Over eons, smaller voids merged, like soap bubbles coalescing, to form even larger, more cavernous supervoids. So you see, these empty places aren't an accident or a fluke. They are a core part of how the universe is built. The voids and the filaments are two sides of the same coin. One couldn't exist without the other. The brilliant web of galaxies owes its very existence to the profound emptiness that surrounds it. And we are heading for the largest, most extreme example of this emptiness ever discovered. The discovery. Finding nothing. Our journey continues through the thinning suburbs of the universe. The galaxies around us are becoming more sparse, the darkness more profound. As we travel, let's think about how we first came to know of this place. Our destination wasn't found by seeing something, but by seeing a lack of something. The year was 1981. An astronomer named Robert Kirshner and his team were working on an ambitious project to create a three-dimensional map of the universe. At the time, our picture of the cosmos was largely two-dimensional. We just saw galaxies projected onto the flat dome of the night sky. But Kirshner's team wanted to add depth. To do this, they measured the redshift of galaxies in a patch of sky in the direction of the constellation Boötes, the herdsman. Because the universe is expanding, nearly every galaxy is moving away from us. The farther away it is, the faster it's moving. This motion stretches the galaxy's light toward the red end of the spectrum. By measuring this redshift, astronomers can calculate a galaxy's distance. It's a slow process, measuring the faint light from galaxy after galaxy to build up a 3D model, slice by slice. As they gathered their data and began to plot their map, a deeply strange picture emerged. In a particular range of distances, where they expected to find a normal distribution of hundreds of galaxies, there was nothing. Their map had a hole in it, a colossal, gaping hole. At first, they must have suspected an error. The common wisdom at the time was that while galaxies might clump together, on the largest scales the universe was more or less uniform. A gap this huge wasn't just unexpected, some models thought it was impossible. But as they surveyed more galaxies around the same area, the hole was still there. It was a real, physical feature of the cosmos. They had discovered a vast region of space, hundreds of millions of light years across, almost entirely devoid of galaxies. They had stumbled upon what would come to be known as the Boötes Void, and what was soon nicknamed the Great Nothing. Imagine being one of those astronomers, looking at your pages of data. You're charting the known universe, and you find a place where the universe simply seems to stop. It was a discovery born not of a celebratory eureka, but of a quiet, creeping sense of disbelief. It was like a mariner, mapping a coastline, suddenly finding that the ocean simply ends. This discovery sent shockwaves through the astronomical community. It challenged everything we thought we knew about the large-scale structure of the universe. And just like that, our whole picture of the cosmos shifted. It was the first powerful evidence that the universe was this strange, foamy structure of filaments and voids. The discovery of the Boötes Void was the moment humanity realized that our universe was mostly empty, and that this emptiness was an essential part of the whole cosmic story. And now, our journey is taking us right into the heart of that discovery, into the center of that great, silent abyss. Arrival at the void. The scale of emptiness. Our journey across the cosmos has taken us around 700 million light-years from home. The familiar constellations, the Milky Way, our local group of galaxies, all are now invisibly distant. The sky around us is a sparse scattering of faint, fuzzy lights. We're on the edge of the Hercules supercluster, one of the vast walls of galaxies that forms a boundary of our destination. Now, we're going to cross that boundary. As we glide forward, the last of the galaxies in the filament behind us fade away. One by one, the distant islands of light wink out. The darkness ahead is no longer punctuated by the hope of another galaxy. It is a deep, velvety, and almost perfect black. We have arrived. We are inside the Boötes Void. Take a moment to let the scale of this place sink in. This region is a roughly spherical area of space measuring 330 million light-years in diameter. That number is so large our minds aren't really built to grasp it. So let's try an analogy. Imagine that our entire Milky Way galaxy, with its hundreds of billions of stars, is shrunk down to the size of a single marble. You hold this marble in the palm of your hand. On this scale, to get to the next big galaxy, Andromeda, you'd have to walk about 25 feet. Now, using that same scale, the Boötes Void would be a city hundreds of square miles in area. You could walk for days from one end of this void city to the other, and our entire galaxy would still just be that tiny marble you left at the very beginning. Let's try another way. Light is the fastest thing in the universe. A beam of light could circle the Earth 7.5 times in a single second. To cross the Boötes Void, that same beam of light would need to travel for 330 million years. By the time it reached the other side, the entire history of mammals on Earth would have unfolded in its wake. The true shock of the Boötes Void comes from what's missing. In a typical slice of the universe this large, astronomers would expect to find at least 2,000 galaxies. 2,000 islands of light, each comparable to our own Milky Way. Instead, as we peer into the darkness, what do we see? We see about 60 galaxies in a space that should hold thousands. Almost everything that should be here is gone. And even those 60 galaxies aren't scattered randomly. Later surveys found something even stranger. The few galaxies that do exist inside the void are all arranged in a narrow, tube-like structure, a lonely filament twisting its way through the center of the immense emptiness. This means if you were to venture away from this one tiny, sparse chain of galaxies, the emptiness would become even more absolute. Let's imagine being on a planet, in one of these 60 lonely galaxies. What would the night sky look like? It would be black. Utterly, profoundly black. From Earth, we can see our sister galaxy Andromeda with the naked eye, 5 million light-years away.
Here, in the heart of the Boötes Void, the nearest galaxy might be tens of millions of light-years distant, completely invisible without a powerful telescope. You'd need equipment far more advanced than anything Galileo had just to know that you weren't alone in the universe. As astronomer Greg Aldering once said, if the Milky Way had been in the center of the Boötes Void, we wouldn't have known there were other galaxies until the 1960s. Think about that. All of human history, all of our science and mythology, would have unfolded under the belief that our galaxy was the entire universe. A single, lonely island of light in an infinite, empty ocean. The discovery of other galaxies, which Edwin Hubble made in the 1920s, would have had to wait for modern telescopes. It's a chilling and deeply isolating thought. That is the reality of the Boötes Void. It is the physical embodiment of cosmic solitude. The science of nothing. What is empty space? Here we are, floating in the center of this great nothing. The silence is absolute. The darkness is nearly perfect. It's tempting to think of this place as a true vacuum, a region of absolute nothingness. But the universe is more subtle than that. Space is never truly empty. So, what is here in the void with us? Even in the most desolate regions, there's a thin, almost imperceptible mist of particles. Stray atoms of hydrogen and helium left over from the Big Bang. There is dust, there are lonely wandering particles, and there are neutrinos, ghostly subatomic particles that stream through the cosmos, barely interacting with anything. And most significantly, there is dark matter. Dark matter is the invisible scaffolding of the universe. We can't see it because it doesn't interact with light, but it has mass, and therefore gravity. In fact, it outweighs all the visible stars and gas by more than 5 to 1. It was the gravity of dark matter that first caused the cosmic web to form. When the voids formed and visible matter flowed out towards the filaments, much of the dark matter flowed out with it, but not all of it. Models predict that even the emptiest voids still have about 10 to 20% of the average density of matter found elsewhere. It's not a true nothing, but a region of profound underdensity. It's like comparing a dense forest to an open plain with only a few scattered trees. The plain isn't empty, but its density is dramatically lower. The Boötes Void is the largest, most empty plain we have ever found. You might be wondering if it could be a gigantic black hole. It's a natural thought, but that's not what this is. A black hole is an immense amount of mass collapsed into a tiny point. The Boötes Void is the opposite. It's defined by a * lack of mass. Besides, we know it's not a black hole because light passes right through it. We can see the faint light of the few galaxies inside it, and the light from galaxies far beyond it, shining through on their way to us. It is genuinely, transparently empty. The leading idea for how this particular supervoid formed is a story of cosmic cannibalism. The theory is that the Boötes Void didn't form as one single entity. Instead, in the early universe, this region was filled with many smaller voids, like bubbles in a foam. Over billions of years, as the universe expanded, these smaller voids began to merge. They flowed together, their boundaries dissolving, until they created one single, colossal supervoid. The tube of galaxies we see running through its middle may be a scar, the remnant of the boundary where two of the final, large voids met, a last ghostly trace of the structure that was once there. The big picture. What voids tell us? As we drift in this silent, empty space, it's worth asking, why does it matter? Why is studying this vast nothingness so important? The answer is that these voids aren't just empty spaces. They are sensitive scientific instruments. Their very existence, their size, and their shape are all tied to the most mysterious forces in the cosmos, especially dark energy. Dark energy is the name we give to the force that is causing the expansion of the universe to accelerate. It's a kind of repulsive pressure, built into the fabric of space itself, that is pushing everything apart. The cosmic web is a delicate balance between the inward pull of gravity and the outward push of dark energy. Voids act like cosmic barometers. Their evolution is driven by dark energy pushing them to expand from within, while gravity tries to hold the surrounding filaments together. By studying the precise shapes and sizes of voids, scientists can measure the strength of dark energy and how it has changed over time. This great nothing, paradoxically, tells us about the most powerful force in the universe. Voids also serve as perfect, sterile laboratories. For instance, by studying how elusive particles like neutrinos travel differently through voids compared to denser regions, scientists hope to measure their properties with incredible precision. The great nothing is the cleanest laboratory we could ever hope for. Our journey is now coming to an end. It's time to leave the profound quiet of the Boötes Void behind. Imagine our vessel turning around, accelerating back towards the distant filaments of light. Slowly, almost imperceptibly at first, the darkness begins to recede. Faint points of light appear in the distance, growing steadily brighter. We are returning to the land of the living, the crowded, vibrant cosmic web. The lonely tube of galaxies within the void shrinks behind us, and we cross back into the bustling superclusters of the universe. The sky once again fills with the light of countless galaxies. The overwhelming emptiness gives way to a familiar, comforting density. We have traveled to the heart of nothingness, and returned. What did we learn there, in the quiet dark? We learned that the bright, beautiful, chaotic universe we see is the exception, not the rule. We live on a small island of matter in a cosmos that is overwhelmingly defined by its absence. The voids are not just gaps, they are the mold that shaped the cosmic web and all the galaxies within it. The silence of the void teaches us to appreciate the chorus of light and life in our own galactic neighborhood. Its vastness gives us a new and profound perspective on our own existence. We are the improbable occupants of a crowded sliver of reality, floating in an ocean of unimaginable emptiness. And in that emptiness, we are finding answers to some of the deepest questions about our universe. As you continue to drift, let the scale of that journey settle in your mind. Let the quiet of the void bring a sense of peace. The universe is vast and silent, but it is also our home. If you enjoyed this quiet journey into science, consider subscribing for more explorations to come. For now, just rest. Let the darkness behind your eyes be as peaceful as the great nothing, and sleep well. Part 2: How astronomers discovered the universe has giant gaps. It is one thing to imagine that space might contain empty places. It is another thing entirely to prove it. When most people look up at the night sky, what they notice first is what is there: stars, constellations, a soft river of light from the Milky Way on a dark night. Even the word universe tends to make us think of things that glow. Galaxies, nebulae, clusters, supernovae, bright objects, crowded places, ancient fires suspended in blackness. And for a long time, that was how human beings pictured the cosmos. A vast place, yes, but still a place in which matter was spread out more or less everywhere, like a fine mist. That assumption made sense. From Earth, the sky does not naturally reveal its depth. It looks like a dome, a flat ceiling of distant lights. Before modern astronomy learned how to measure the true distance to galaxies, there was no easy way to tell whether the universe was arranged in a smooth pattern, a random pattern, or a deeply uneven one. The stars above us gave the impression of abundance. The deeper our telescopes looked, the more galaxies they found. And so it was easy to believe that if you kept going, if you kept mapping farther and farther out, the universe would remain full. But the strange thing about science is that sometimes it moves forward not by finding something, but by realizing that something expected is missing. That is what happened here. Astronomers did not set out thinking they were about to discover giant holes in the universe. They were simply trying to do something patient and methodical. They wanted to turn the night sky into a map with depth. Not just a picture of where galaxies appeared on the sky, but a true three-dimensional portrait showing which ones were near, which ones were far, and how they were arranged in space. To do that, they relied on one of the most important tools in modern cosmology: redshift surveys. Because the universe is expanding, light from more distant galaxies is stretched toward longer, redder wavelengths, and that shift can be used to estimate distance. In 1981, Robert Kirshner and his colleagues reported evidence for an enormous nearly empty region in the direction of Boötes, and a larger follow-up survey in 1987 confirmed a roughly spherical void with a radius of about 62 megaparsecs, or about 200 million light-years. There is something beautifully quiet about that method. No dramatic explosion, no sudden flash in a telescope. Just spectra, numbers, and the patient act of measuring how far away one galaxy is, then another, until the flat sky begins to open into depth. If you can picture it, it helps. Imagine standing in a dark field at night and seeing thousands of lanterns floating in the distance. At first, all you know is where they appear from your point of view. One to the left, one to the right, a faint one near the horizon. But you do not yet know which lantern is 10 meters away, which is 100, and which is 1,000. Now imagine you have a way of estimating the distance to each lantern. Slowly, the scene changes. It stops being a flat wall of lights and starts becoming a real landscape. That is what astronomers were doing with galaxies. And at first, the results were already surprising. The universe was not smooth. Galaxies did not lie in a calm, even scatter. They grouped together. They formed clusters. They stretched into chains and sheets. Even before anyone became famous for a giant void, the deeper maps were already hinting that the cosmos had structure on truly enormous scales. Matter was social. Gravity had spent billions of years gathering it into neighborhoods, city-states, and vast metropolitan regions of light. But structure alone was not the real shock. The real shock came when the mapping became good enough to show not only where matter liked to gather, but where it had almost entirely failed to gather at all. That difference is important. A sparse region is not the same as a void. A quiet part of space is not the same as a place so underpopulated that it feels almost forbidden. Astronomers expected some unevenness. What they did not expect was the possibility of regions so large, and so empty, that they seemed to challenge their mental picture of the whole universe. It must have felt strange, almost suspicious, when the first gap appeared in the data. Because scientists are careful people, especially when a discovery seems too dramatic. When an empty stretch shows up where many galaxies should have been, the first thought is usually not wonder. It is doubt. Was the telescope looking in the wrong place? Was the sample incomplete? Was the analysis introducing a false pattern? Had something gone wrong with the measurements, the selection, or the assumptions? That skepticism was healthy. It had to be. If you are going to claim that an enormous region of the universe is nearly empty, you need to rule out every more ordinary explanation first. So the work continued. More galaxies were measured. More redshifts were taken. More sky was checked. And the gap remained. Not a little gap. Not a modest thinning. A genuine absence on a scale that was hard to absorb. The region in Boötes became the most famous example. Later descriptions of the Boötes Void put it at roughly 330 million light-years across, centered about 700 million light-years away, with only around 60 known galaxies where astronomers would have expected something closer to 2,000 in a similar volume. NASA has also highlighted the odd detail that the galaxies found inside it seem to trace a loose tube-like pattern rather than filling the space evenly. If you slow down and sit with those numbers, they do not feel like numbers anymore. They feel like atmosphere. 330 million light-years across. That means light, the fastest thing we know, would spend 330 million years crossing it. Not crossing the whole observable universe. Not crossing some grand mythical distance. Just crossing one especially empty region within it. And only around 60 galaxies inside. Even saying that softly has a strange weight to it. Because by human standards, 60 sounds like a crowd. 60 people in a room is plenty. 60 houses on a street is a neighborhood. 60 cities on a map is a lot to keep track of. But on that scale, inside that volume, 60 is almost nothing. It is the cosmological equivalent of finding a few grains of sand in a space that should have held a beach. That was the moment the emotional picture of the universe changed. Until then, many people, including many scientists, still carried a lingering intuition that the cosmos was mostly full. Maybe not equally full in every direction, but full enough that if you backed away far enough, things would average out into a kind of grand uniformity. The giant voids broke that feeling. They suggested that the universe is, in a very deep sense, shaped just as much by absence as by presence. And once astronomers had seen that once, they began seeing it everywhere. Not one void, but many. Not just clusters, but clusters separated by great underdense regions. Not a random spray of galaxies, but something more like foam, lace, or a web. Bright filaments and walls of galaxies surrounding dark cavities. The cosmic web, as it came to be called, was not just a poetic phrase. It was the emerging geometry of the large-scale universe. Modern reviews describe cosmic voids as major low-density features of that web, and not merely empty leftovers, but important structures for understanding how the universe grows and evolves. There is a quiet beauty in that realization. The universe is not a brick of matter. It is more like a sponge of light and darkness. A delicate architecture in which the bright parts are only one side of the design. The empty parts are not mistakes. They are part of the pattern. And once you begin thinking that way, the discovery of the giant gaps feels less like an anomaly and more like a revelation of the universe's deeper style. Still, it is worth lingering with the human side of it, because this was not just a graph on paper. It was a philosophical shift disguised as astronomy. Try to imagine being one of those astronomers staring at the early maps. You begin with a simple survey. You expect irregularity, certainly. But you also expect continuity. You expect the universe to keep offering you galaxies as you look farther outward. Then, instead, your map opens into a silence. A huge silence. A silence measured not in missing stars, but in missing galaxies. Entire galactic systems, each containing billions of stars, simply absent from a region where they should have been. That is a strange thing to discover. It means there are places in the universe where the night sky, from within one of the few galaxies there, would be almost heartbreakingly dark. No rich neighboring swarm. No obvious nearby galaxy glowing like Andromeda does in our own sky. Just a small island of light and a vast surrounding blackness. One astronomer once pointed out that if the Milky Way had been sitting deep inside such a void, humanity might have taken much longer to realize that other galaxies even existed. That thought stays with you. It means our cosmic self-understanding is partly a matter of address. We learned the universe was full of other galaxies because we happened to live in a region where those galaxies were visible enough to find. In a lonelier neighborhood, the story of astronomy might have unfolded more slowly, and our sense of our place in the cosmos might have been even more isolated for much longer. NASA and popular astronomy coverage have both emphasized this thought experiment in discussions of the Boötes Void. That idea has a gentle sadness to it. It reminds you that knowledge is not only a matter of intelligence. It is also a matter of what the universe allows you to see from where you happen to stand. And in a way, that is part of what makes the discovery of cosmic voids so moving. It took patience, measurement, and imagination to realize that the universe was stranger than it looked from our small corner of it. The giant gaps were not obvious to the eye. They had to be inferred. They had to be earned through careful mapping, through the willingness to trust a pattern even when that pattern first looked unbelievable. There is also something deeply soothing in the scale of it. Not because emptiness itself is comforting, exactly, but because it changes the rhythm of how you picture the cosmos. The universe stops feeling like a frantic crowd of objects and starts feeling more spacious, more balanced, almost architectural. Light here, darkness there, a web stretched over vast hollows. Not chaos, but form. And that brings us to another important point. The voids were not discovered because astronomers were looking for nothing in some mystical sense. They were discovered because nothing, when it appears consistently in a map, becomes a kind of something. It becomes evidence, pattern, structure. The absence is no longer a blank. It becomes data. That may be the most beautiful part of the whole story. Science has a way of teaching us that emptiness is not always emptiness. A silence can contain information. A missing feature can reveal more than a bright one. A gap in a map can tell you how the whole landscape was built. In the case of the giant cosmic voids, that lesson was profound. Once astronomers realized the gaps were real, they also realized those gaps were clues to the history of the universe itself. Matter had not simply been sprinkled evenly through space. It had flowed. It had gathered under gravity into dense filaments and clusters, leaving other regions progressively emptier. The voids were records of that long migration. They told a story about how the early universe evolved from tiny differences into a grand large-scale pattern. But for this part of the journey, what matters most is the moment of recognition. The moment when the universe ceased to be merely full of things, and became a place where absence had shape. The moment when astronomers stopped thinking only in terms of galaxies and began thinking in terms of the spaces between them. The moment when a blank region in the maps of Boötes turned into one of the most haunting discoveries in modern cosmology. If these slow journeys through space help you unwind, you can always leave a quiet like, subscribe, or share where you're listening from tonight. It is always calming to imagine these thoughts drifting through different rooms, different cities, and different corners of the world while the universe remains vast above all of us. And maybe that is the perfect place to pause. Because now we know how the giant gaps were found. Not by accident, exactly, but by the slow sharpening of our vision. By turning the sky into depth. By trusting the evidence. By following the pattern until the pattern revealed that the cosmos is not only made of galaxies, but also of great, silent chambers between them. And once you know those chambers are real, another question naturally begins to rise. What, exactly, is a cosmic void? Not just emotionally, not just visually, but scientifically. What counts as a void? How empty is empty? And what really separates an ordinary dark region of space from one of these immense, almost dreamlike deserts of the universe? That is where the journey leads next. Part 3. What is a cosmic void? A cosmic void is one of the strangest things astronomy has ever named, because it is famous not for what it contains, but for what it lacks. That alone gives it a strange kind of gravity in the imagination. We are used to being fascinated by presence. We look towards stars because they shine. We remember galaxies because they swirl with light. We think of black holes because they bend space and swallow matter. But a void asks for a different kind of attention. It asks you to notice an absence so large, so quiet, and so real that it becomes one of the defining features of the universe itself. And that can be hard to picture at first. Because when people hear the word void, they often imagine the wrong thing. They imagine a hole punched into reality. A tear in space. A place where the universe has somehow gone missing. Something dangerous, unnatural, or broken. But a cosmic void is none of those things. It is not a rip in the fabric of the cosmos. It is not the edge of existence. It is not a black hole, and it is not a portal. It is simply a region of the universe where matter, especially galaxies, is far more sparse than average. That may sound like a small distinction, but it changes everything. To understand it, it helps to step back and soften the mental picture most of us carry. If you imagine the universe as a place where galaxies are scattered more or less evenly in all directions, then a void sounds like an exception, a blank patch, a mistake. But that is not how the large-scale universe actually looks. When astronomers map galaxies across enormous distances, they do not see a smooth fog of matter. They see structure. Galaxies gather into groups, clusters, walls, and long filaments. Between those brighter structures are large underdense regions, and together that pattern forms what scientists call the cosmic web. That phrase, cosmic web, is more than a poetic label. It is one of the best visual guides we have. Imagine a vast three-dimensional network of luminous strands, like a web made of galaxies. Where the strands cross, matter piles up into clusters and superclusters. But between the strands are cavities, huge chambers of relative emptiness. Those chambers are the voids. In other words, voids are not the leftovers of the universe. They are part of its architecture. The bright regions and the empty regions belong to the same design. So when astronomers say cosmic void, what they usually mean is a large underdense region in the cosmic web, not absolute nothingness, not the absence of space itself, just a place with far less matter than the cosmic average. Modern reviews describe voids as low mass density regions on intergalactic scales, often tens of megaparsecs in radius, occupying much of cosmic volume while containing only a small fraction of its galaxies and matter. And here is where the idea becomes both simpler and stranger. A void is empty only by comparison. That matters. Because in everyday language, empty usually means nothing at all. An empty room may still contain air, dust, and the faint smell of old wood, but we still call it empty because compared to a furnished room, it feels bare. A cosmic void works a little like that. Compared to the dense strands and clusters of the cosmic web, it is astonishingly sparse. But that does not mean it contains nothing. A void can still hold faint gas, thin plasma, dark matter, stray radiation, and sometimes even a few lonely galaxies. NASA notes that even the intergalactic medium between galaxies is not truly blank, but an extremely thin gas and plasma. That is one of the most important ideas to settle into before going further. A void is not a perfect vacuum. It is not an erased region. It is more like a cosmic countryside so sparsely populated that the nearest towns are unimaginably far apart. In fact, astronomers do not all use one single perfect definition for where a void begins and ends. That may sound surprising, but it makes sense once you think about it. Nature does not draw bold lines around its structures. A mountain gradually becomes a hillside, and a hillside becomes a plain. In the same way, a cosmic void is not always bounded by a neat invisible shell. Different teams use different algorithms and different thresholds when identifying voids in galaxy surveys. Recent reviews openly note that there is no single universal definition of a cosmic void, even though everyone agrees they are large underdense regions in the cosmic web. That uncertainty is not a weakness. It is just part of studying something enormous and subtle. Some methods look for roughly spherical regions where the density falls below a chosen threshold. Others treat the galaxy distribution more like a landscape, letting low-density basins spread outward until they meet denser ridges, a bit like rainwater collecting in valleys. In practical survey work, void-finding methods often target regions with density contrasts close to a tenth of the cosmic mean and with sizes above a minimum radius, but the exact details vary from one catalog to another. So if you ever see one source call a region a void, and another describe a slightly different boundary, that does not mean the science is confused. It means the object itself is more like a quiet landscape than a hard-edged container. There is something soothing about that, actually. Even the emptiest structures in the universe are not rigid. They fade into their surroundings. They have shape, but not in the way a marble has shape. They are more like weather systems, valleys, or bubbles in foam. And foam may be the best analogy of all. If you have ever looked closely at soap foam, bread dough, or even the inside of a sponge, you have already seen something that resembles the large-scale universe. The important material gathers along thin surfaces and edges, while the interiors of the bubbles remain mostly open. From far away, your attention goes to the bright or solid parts. But in terms of volume, the hollow cells dominate. In a similar way, the universe is not mostly made of dense, glowing regions. By volume, it is dominated by the wide, quiet spaces between them. NASA's educational materials describe the large-scale universe as having a bubbly structure of sheets and filaments punctuated by large voids. That image helps because it prevents one common mistake. A void is not something separate from the rest of the cosmos. It is not floating somewhere outside the web. It is one of the cells inside the web. It exists because the web exists. And that leads to a deeper question. Why do voids exist at all? The calm answer is gravity. Not dramatic gravity, the kind that crushes stars or bends light around black holes, but patient gravity. The kind that works over billions of years, slowly drawing matter from one region to another. In the early universe, matter was distributed almost evenly, but not perfectly. Tiny fluctuations in density gave gravity something to work with. Regions that were slightly denser pulled in more material. Over immense stretches of time, those denser regions grew into the filaments, walls, and clusters we see today. And as matter flowed toward those crowded zones, other regions were left progressively emptier. Voids are, in a sense, the places matter drained away from. That means a void is not a static blank. It is the result of motion, a quiet aftermath of cosmic migration. Even now, voids are not inert. Modern cosmology treats them as evolving structures. They tend to expand relative to denser surroundings, and in many cases they can grow or merge with neighboring underdense regions, becoming larger over time as matter continues to collect elsewhere. Recent reviews describe them as regions where cosmic expansion and acceleration are especially dominant, while earlier NASA outreach also notes that larger voids may form through the combination of smaller ones. This gives voids a strange personality. They are shaped by what is not happening there. No great collapse into galaxy clusters. No thick knots of matter. No bustling cosmological city. Instead, they are regions where gravity's usual building projects happen somewhere else. And yet, they are not lifeless in a complete sense. A few galaxies can still exist inside a void. Some are isolated. Some are small. Some are gas-rich and still making stars in relative solitude. The Boötes Void, for example, is famous precisely because it is so empty compared to expectation, yet even their astronomers have found a small number of galaxies rather than absolute nothing. Studies of void galaxies also suggest that many of them are relatively gas-rich and low luminosity, which makes them especially interesting to astronomers. That is an important emotional correction. A void does not have to be completely barren to feel unimaginable. Sometimes a handful of galaxies inside a region hundreds of millions of light-years across is even more haunting than pure nothingness, because it makes the scale of the emptiness easier to feel. A few scattered islands only emphasize the size of the sea. Try to picture that slowly. Take the Milky Way, with its hundreds of billions of stars. Then imagine another galaxy like it, and another, and another. In dense regions of the universe, galaxies can appear in rich gatherings, whole communities of light linked by gravity. But inside a void, the spacing changes radically. The neighborhoods thin out. The traffic disappears. The familiar cosmic crowd falls away. If you were standing on a world deep inside such a region, the broader universe might appear much lonelier than it does from where we happen to live. Astronomers have even pointed out that had the Milky Way been buried in the center of a giant void, humanity might have taken far longer to realize other galaxies existed at all. There is something almost tender in that thought. It reminds you that our understanding of the cosmos depends not only on intelligence, but on location. The universe reveals itself differently depending on where you are standing inside it. This is one reason voids feel so rich as a subject, even though they are about emptiness. They are not just gaps in the map. They are alternate kinds of cosmic environment. Places where the rules are the same, but the scenery is radically different. And if you listen closely, you can hear how the language starts to shift around them. Dense regions of the cosmos are often described like cities, hubs, knots, or intersections. Voids invite a different vocabulary. Silence, distance, drift, isolation, openness. Their science is precise, but their emotional effect is almost literary. Still, it is worth keeping one foot firmly in the science, because the science itself is beautiful enough. A typical void is large. Not merely large by human standards, but large even by galactic ones. Many have sizes measured in tens of megaparsecs, which means tens of millions of light years. Some are larger still, rising into the category often called supervoids. NASA's educational material describes voids as reaching several hundred megaparsecs in size, while more recent reviews describe common void radii in the tens of megaparsecs and confirm that these regions occupy the majority of the universe's volume. That scale matters because it explains why voids are not curiosities at the margins of cosmology. They are among the biggest patterns the universe makes. And that is also why scientists care about them so much. At first glance, you might think the best place to study the universe would be where the most things are happening, in galaxy clusters or in brilliant active systems. But voids offer a different kind of advantage. Because they are less cluttered by violent nonlinear processes, they can serve as unusually clean laboratories for studying the underlying rules of the cosmos. Recent reviews emphasize that void properties can help probe cosmology, including gravity, dark energy, neutrino mass, redshift distortions, weak lensing, and the growth of structure. That is a remarkable twist. The emptiest places in the universe may tell us some of the most important things about the universe as a whole. A void, then, is not just an empty room in the cosmic house. It is also a measuring chamber. A place where the background tendencies of the universe can be studied with unusual clarity. And perhaps that is why the word emptiness feels too simple for what a void really is. Because a void is not merely empty. It is underfilled. It is shaped by history. It has boundaries made not of walls, but of contrast. It evolves. It can expand. It can merge. It can contain traces of matter without ceasing to be a void. It can be scientifically useful and emotionally unsettling at the same time. It is one of those rare ideas that becomes more interesting the more carefully you define it. So let us say it plainly, in the calmest and most accurate way. A cosmic void is a very large region of the universe where the density of matter, especially galaxies, is much lower than average. It lies between the filaments, walls, and clusters of the cosmic web. It is not perfectly empty, not universally defined with one exact border, and not separate from the rest of cosmic structure. It is one of the main structural features of the universe itself. Once you understand that, something subtle changes. The word void stops sounding like a dramatic mystery and starts sounding like a precise kind of place. A real environment. One with its own history, its own texture, its own scale. And now, quietly, another question begins to rise. If a cosmic void is the name for these immense underdense chambers in the cosmic web, then which one became the most famous of all? Which one startled astronomers enough to change how people imagined the universe? Which emptiness became so large, and so iconic, that it came to stand for cosmic loneliness itself? That is where the story drifts next. And if this kind of slow exploration helps you settle in for the night, you can leave a quiet like, subscribe for more calm journeys through science, and, if you feel like it, share where in the world you're listening from. There is something comforting about imagining these thoughts traveling softly through bedrooms, late-night desks, and quiet corners of the planet, while the great dark architecture of the universe waits above us. Part 4. Meet the most famous giant void ever found. Of all the empty places human beings have ever discovered, one of them feels less like a scientific object and more like a whisper. It has a name, of course. Every mystery eventually does. But before the name settles in, before the measurements and coordinates and surveys begin to make it feel familiar, there is only the feeling of it. A feeling that somewhere out in the vast architecture of the cosmos, there exists a region so unnervingly empty that it seems to sit outside ordinary intuition. Not beyond the universe, not outside reality, but inside it, quietly occupying an impossible amount of space with almost nothing at all. And for many people, the name that has come to represent that feeling more than any other is the Boötes Void. If cosmic voids are the silent chambers of the universe, then the Boötes Void is the one that became legendary. It was discovered in 1981 during a redshift survey led by Robert Kirshner and his colleagues, who found that where they expected a normal distribution of galaxies, there was instead a vast region nearly devoid of them. Later descriptions from NASA summarize it as being roughly 250 to 330 million light-years across, in the direction of the constellation Boötes, with only about 60 known galaxies inside where far more might have been expected. Even the name carries a certain distance. Boötes, an old constellation, hanging in the northern sky, known since antiquity. To most people, it means very little. Just another unfamiliar arrangement of stars. But now its name is tied forever to one of the most haunting discoveries in cosmology, a place sometimes nicknamed the Great Void, and more dramatically still, the Great Nothing. NASA's own outreach has used both Boötes Void and the Great Void when describing it. There is something wonderfully human about that. Scientists may speak with precision, but when confronted with a place like this, even precision starts to soften into atmosphere. The Great Nothing. It sounds like mythology, like a forbidden province at the edge of an old map. And yet it is real, not imagined, not exaggerated into existence by fear or poetry. It is there, patiently occupying a colossal volume of space, whether we think about it or not. If you try to picture it too quickly, the mind tends to fail in predictable ways. It shrinks the void into something manageable. A dark cloud. A black patch. A hollow bubble floating somewhere out there among brighter things. But the Boötes Void does not deserve to be imagined quickly. It needs slowness. Its scale only begins to make sense when you allow your thoughts to move at the pace of the distances involved. So let us slow down. Our own galaxy, the Milky Way, is about 100,000 light-years across. That already sounds huge because it is huge. Light, moving at the fastest speed in nature, needs 100,000 years to travel from one side of it to the other. Everything in ordinary life disappears inside a number like that. Civilizations rise and vanish. Mountains change shape. Languages are born and forgotten. And yet the Boötes Void is not 1 or 2 Milky Ways across. It is not 100. It is not 1,000. It is so large that if you laid galaxies like ours inside it, they would feel less like a packed collection and more like a few scattered thoughts drifting through a cathedral of darkness. NASA notes that the distance to Andromeda, our nearest major galactic neighbor at about 2.5 million light-years, would cover only about 1% of the Boötes Void's width. That comparison helps because Andromeda already feels far away. On a human scale, it is not far. It is beyond far. It is a distance so extreme that ordinary comparison breaks down. And yet in the context of this void, that vast gap becomes almost a small unit of measure. A mere fraction. Just one quiet step inside a much larger emptiness. No wonder the Boötes Void became famous. It was not only large, it was emotionally legible. It was the kind of discovery people could feel. When astronomers described a region with only about 60 galaxies where thousands might have been expected, the numbers did not just stay on the page. They translated into mood, into a new sense of what the universe could be like in some of its loneliest districts. NASA's description of the Boötes Void explicitly notes that roughly 2,000 galaxies might be expected in a similarly sized region, yet only about 60 have been found there. And even those 60 do not fill the void in any comforting way. One of the strangest details is that the galaxies found there are not spread evenly like a faint dusting. NASA describes them as lying in a kind of tube-shaped arrangement through the emptiness, which somehow makes the whole thing feel even stranger. It is as if the void tolerated only the thinnest trace of structure passing through it, and left the rest in silence. That detail matters more than it first appears to, because people often assume that if a void is not perfectly empty, the mystery somehow fades. But the opposite is usually true. A handful of galaxies inside such a massive underdense region does not make the Boötes Void less eerie. It makes it more vivid. Absolute nothingness is almost too abstract to imagine. A few lonely galaxies, on the other hand, give the emptiness shape. They become tiny candles in an enormous abandoned hall. And the hall itself is not nearby. The center of the Boötes Void lies roughly 700 million light-years from Earth, far beyond our local galactic neighborhood, far beyond the familiar places of popular astronomy. It lives in a realm where the universe already feels less like a collection of individual galaxies and more like a landscape of large-scale structure, where light and emptiness are arranged like weather patterns across unimaginable distances. That is part of why the discovery was so important. It did not just identify one weird region. It helped confirm that the universe on its largest scales is not a smooth spread of matter, but a web. A delicate arrangement of filaments, clusters, and walls surrounding great underdense regions. In that picture, the Boötes Void was not merely a curiosity. It was a revelation. It was one of the first dramatic proofs that the empty spaces of the cosmic web were real, enormous, and worthy of study in their own right. The original 1981 paper described the observation as a large volume, on the order of 1,000,000 cubic megaparsecs, nearly devoid of galaxies. If you imagine being alive when that realization first settled in, you can feel some of the shock of it. Before the maps became detailed enough, the universe could still be imagined as crowded in a broad, forgiving sense. Dense here, sparse there, but always continuing. Always supplying more galaxies if you looked in the right direction. The Boötes Void interrupted that feeling. It announced, very quietly, that there were places where the universe did not continue in the way intuition expected. It opened into silence. And because it was one of the first great examples to become widely known, it entered the imagination almost as a character. Not in the dramatic sense. Not as an enemy or a supernatural force. But as a place with a personality. Some regions of space feel fertile. Some feel violent. Some feel ancient. The Boötes Void feels solitary. It feels paused. It feels like a place where the normal social life of matter has thinned into near absence. That emotional texture is one reason it remains so memorable, even now. Because strictly speaking, the Boötes Void is not always described today as the single largest underdense region ever proposed. Later studies have discussed enormous supervoids, including the Eridanus supervoid, which Fermilab described in 2022 as about 1.8 billion light-years wide and among the largest structures known. But Boötes remains the iconic giant void, the one that first defined the idea for many people and became the most recognizable symbol of cosmic emptiness. That distinction is important, especially for clarity. When people ask about the largest void ever discovered, the honest answer depends a little on how scientists define the structure, how the boundaries are measured, and whether they are talking about famous classic voids or more complex supervoid candidates. But when people imagine the great emptiness of the universe, it is often the Boötes Void they are really asking about. Not because it is the newest or the most statistically debated case, but because it is the one that entered astronomy's shared imagination so completely. It became, in a way, the face of emptiness. And perhaps that is why it fits so naturally into quiet, late-night thought. The Boötes Void is not just a scientific entry in a catalog. It is a perspective changer. Once you know it exists, the universe feels different, more spacious, more architectural, more willing to create not only blazing things, but also regions defined by almost total restraint. Imagine for a moment that you could stand on a world inside one of the few galaxies drifting through that vast emptiness. The sky would still contain stars from your own galaxy, of course. Nearby suns, nebulae, perhaps the familiar glow of whatever stellar structure surrounded you locally. But the larger universe might feel far quieter than ours does. The great congregation of neighboring galaxies that helps reveal the cosmic abundance from our own region might be missing, or so faint and distant that it would not shape culture or philosophy in the same way. NASA quotes astronomer Greg Aldering as saying that if the Milky Way had been at the center of the Boötes Void, we might not have known other galaxies existed until the 1960s. That thought is one of the most haunting in all of cosmology. It means that our understanding of the universe is partly geographic, not only intellectual, but geographic. We know what we know because we happen to live in a region where the broader structure of the cosmos is visible enough to be discovered. In a lonelier address, the story of astronomy could have been delayed by generations. Our sense of cosmic community might have been dimmer for much longer. And that gives the Boötes Void an almost philosophical role. It is not just a place. It is a reminder that knowledge depends on position. That what the universe allows a civilization to see from its own neighborhood shapes how quickly that civilization can understand the whole. That is such a gentle and unsettling lesson that it almost sounds like literature. But it is hidden there in the science. There is also another reason the Boötes Void stays with people. It makes scale feel personal in a strangely quiet way. A galaxy cluster is huge, yes, but it is a crowded kind of huge. A supernova is powerful, but it is a dramatic kind of powerful. The Boötes Void offers something different. It offers emptiness on a scale so large that it starts to feel contemplative. It asks not for excitement, but for surrender, for stillness, for the slow recognition that the universe is not in a hurry to fill itself. That tone may be why the subject feels so suited to sleep, or to late hours, or to those moments when the mind wants space more than spectacle. Not because the void is comforting in any simple way. It is too strange for that. But because it invites a certain softness of thought. It reminds you that reality is under no obligation to be crowded, or loud, or obvious. Sometimes the universe reveals itself most deeply through the places where almost nothing happened. And even that phrase, almost nothing, deserves care. Because the Boötes Void is not a tear in the cosmos. It is not some forbidden rupture. It is part of the same universe that made the Milky Way, the Sun, the Earth, and every human life that has ever unfolded beneath the stars. It follows the same physical laws. It arose through the same long story of gravity and structure formation. Matter gathered elsewhere, and in gathering elsewhere, it left behind these enormous chambers of relative emptiness. NASA's description of cosmic voids frames them as natural products of gravity, with matter clustering into denser regions while voids are left behind and can merge into larger ones. So the Boötes Void is not an exception to the universe. It is one of the universe's signatures, a signature written in absence, a cathedral built from missing galaxies, a kind of dark room in the larger cosmic house, where the walls are not solid but statistical, and the silence has lasted for billions of years. If this kind of slow wandering through astronomy helps you settle into the night, you can leave a quiet like, subscribe for more calm journeys through space and science, and, if you feel like it, share where you're listening from. It is always a lovely thing to imagine these thoughts drifting softly through different time zones, different bedrooms, different quiet corners of the world, while the universe remains immense and patient above us all. And now that the Boötes Void has a shape in the mind, another question begins to emerge. Not just what it is, or where it is, but how large it really feels when compared to the things we already know. How many Milky Ways could fit across it? How it compares to galaxy clusters, to superclusters, to the ordinary scales our minds use when they try to climb upward from Earth into the deeper cosmos. Because saying that something is hundreds of millions of light years wide is one thing, feeling it is another. Part 5. How big is this void compared to galaxies, clusters, and the Milky Way? There are some ideas in science that are hard because they are technical. And then there are ideas that are hard because they are simply too large. The Boötes Void belongs to that second category. Its difficulty is not really in the math. It is in the feeling. It is in the way the mind quietly gives up when asked to compare something so vast to the things it already knows. We can say that the Boötes Void is hundreds of millions of light years across, and the sentence will sound impressive, maybe even beautiful, but it will not yet feel real. The number enters the ears, but it does not quite settle into the imagination. So for this part of the journey, let us do something gentler. Let us not try to conquer the size all at once. Let us approach it slowly, in steps, the way someone might walk deeper into a dark cathedral, allowing the scale to reveal itself gradually. We will begin with the things that are familiar. Then we will move outward, from the Earth, to the solar system, to the Milky Way, to the neighboring galaxies, to the larger structures of the cosmos. And only then, when the mind has had time to stretch, will we return to the void itself. Because that is the only honest way to understand something like this. You do not understand a giant cosmic void by staring directly at the number. You understand it by noticing how effortlessly it swallows everything else. Let us begin close to home. The Earth is large enough to contain every city, every ocean, every mountain range, every life story that has ever unfolded for our species. It feels complete, total. When you live on the surface of a planet, it is easy to mistake it for the whole stage. But in cosmic terms, Earth is tiny. A small rocky world circling an ordinary star. If you were to compare the sun to a front door, the Earth would be smaller than the head of a pin. And even that comparison is only meant to soften the truth, not fully express it. Then there is the Moon, our nearest companion in space. It sits about 384,000 kilometers away, close enough that light from it reaches us in just over 1 second. On human terms, that distance already feels extraordinary. It took human beings immense effort to cross it. And yet the Earth and Moon are, cosmically speaking, almost touching. If we continue outward, we reach the Sun, about 8 light minutes from Earth. Light, which could circle the Earth more than 7 times in a single second, still needs over 8 minutes to travel from the Sun to your face. That alone is enough to make daily life feel very small and very precious. The sunlight warming your skin began its final journey before you consciously noticed the morning. But even the solar system, so vast in our ordinary imagination, is still only a tiny local arrangement around one star. If you include the outer reaches of the solar system, the great cloud of icy bodies thought to surround it, the whole thing might stretch across light years. That sounds large, and it is. Yet the nearest star beyond the Sun, Proxima Centauri, is still more than 4 light years away. The stars are not arranged like neighboring houses. They are more like distant lanterns scattered across a continent of dark air. And then, beyond the local stars, there is the Milky Way. Now the scale starts to change in a way the mind can feel. Our galaxy is not a cluster of a few hundred stars. It is a vast spiral city containing hundreds of billions of them. A slow-turning island of light, dust, gas, planets, black holes, stellar nurseries, ancient remnants, and quiet regions where nothing much happens at all. From one side to the other, the Milky Way is roughly 100,000 light years across. Pause there for a moment. 100,000 light years. That means that if a beam of light began at one edge of our galaxy, it would take 100,000 years to reach the other side. Not 100,000 kilometers. Not 100,000 miles. 100,000 years. By the time such a beam completed that journey, human civilization would be almost unrecognizable. The pyramids, ancient empires, languages, religions, entire ages of history, all of that would barely register compared to the crossing time of our own galaxy. And yet, magnificent as the Milky Way is, it is still only one galaxy. Now imagine taking that entire 100,000 light-year structure and setting it beside the Boötes Void. The Milky Way would not look like a rival. It would not even look like a meaningful fraction. If the Boötes Void is about 300 million light-years across, Then you could line up roughly 3,000 Milky Ways side by side just to span its width. 3,000 entire galaxies like our own, placed edge to edge, and only then would you begin to cross the emptiness. That comparison helps because it turns the void from an abstract number into a relationship. The Milky Way is not small in any everyday sense. It is enormous. It contains the Sun, Earth, every ancestor you have ever had, every future child who will be born on this world if humanity endures, and countless places no human will ever visit. And still, compared to the Boötes Void, it becomes almost delicate. A small pattern inside a much larger silence. But perhaps galaxies feel too abstract as units, so let us move outward one step more. The nearest major galaxy to us is Andromeda. It sits about 2.5 million light-years away. That is already such a large distance that it seems to belong to myth more than measurement. The light we see from Andromeda tonight began its journey long before modern civilization existed. It left when human history was being written in forms we barely remember. Andromeda and the Milky Way are the two largest members of what is called the Local Group, a small family of galaxies bound together by gravity. This group contains dozens of galaxies, though most are small dwarf systems. If you imagine the Milky Way not as alone, but as part of a neighborhood, the Local Group is that neighborhood. And even that neighborhood is small. The Local Group spans only around 10 million light-years or so, depending on how generously you define its outskirts. On cosmic scales, it is a modest district, a little gathering of islands. Now place that inside the Boötes Void. The whole Local Group could fit inside it again and again and again, with enormous distances left over on every side. You would not just have room for our galactic neighborhood once. You would have room for it dozens of times across, and still the emptiness would continue. That is when the feeling begins to shift. The void is not merely bigger than galaxies. It is bigger than galactic neighborhoods. It does not just make one galaxy feel small. It makes the social life of galaxies feel small. And if we keep moving outward, the comparison becomes even stranger. Beyond the Local Group lies the Virgo cluster, a much richer gathering of galaxies. This is a true cluster, a great concentration of matter containing thousands of galaxies, all bound together in a dense, enormous assembly. Our Local Group is not inside the Virgo cluster, but we exist in the larger region influenced by it. In a sense, Virgo is one of the major hubs in our wider cosmic area, and the Virgo cluster is vast. Its central region spans many millions of light-years. It is one of those places where the universe feels busy, where galaxies crowd together, where gravity has spent billions of years building a bright and populous center. Yet even a galaxy cluster, impressive as it is, does not challenge the scale of the Boötes Void. You could imagine drifting across the Virgo cluster and seeing galaxy after galaxy, light after light, one giant system after another. It would feel full, alive, cosmically urban. But then the Boötes Void appears in the mind, and the cluster becomes one knot in a much larger geometry. That may be one of the most interesting emotional facts about scale in astronomy. Density can fool us. A crowded region feels important because it is bright and busy. But the larger pattern is often ruled not by the densest places, but by the emptiest ones. The voids are like that. They dominate not by spectacle, but by sheer volume. Now let us step outward again, to superclusters. A supercluster is not a simple, tight bundle like an ordinary galaxy cluster. It is more like a continent of structure. A broad region in which galaxy groups and clusters are linked across vast distances. Our own galaxy belongs to a region often referred to as Laniakea, a supercluster-scale structure stretching across roughly 500 million light-years. That number is useful here because, for the first time, we are comparing the Boötes Void to something that is not much smaller than it. Laniakea is huge. Truly huge. It contains the Milky Way, the Local Group, the Virgo cluster, and many other structures besides. It is the kind of thing that already feels like a grand answer to the question of how large cosmic structures can become. And yet the Boötes Void stands comfortably in that same conversation. That is worth sitting with. The void is not merely comparable to a galaxy or a cluster. It is comparable to the largest named structures human beings use to describe our place in the cosmos. It belongs to the scale of superclusters. It is part of the architecture at which the universe stops feeling like a collection of objects and starts feeling like geography. At that point, you are no longer talking about destinations. You are talking about landscapes. And that is why ordinary analogies begin to strain. The Boötes Void is too large to be a room, too large to be a field, too large even to feel like a sea. It is more like a climatic region in the universe, a vast province of underpopulation, where the usual crowding of galaxies gives way to a long and patient thinness. There is another way to feel this. Imagine that the Milky Way were reduced to the size of a grain of sand, not a pebble, a grain of sand. On that scale, Andromeda would be another grain some distance away. The local group would become a small scattering of grains across a room. A galaxy cluster might feel like a dense handful of sand. A supercluster might become a web of dust stretched across a city block. And the Boötes Void? It would still be the long open space between those structures. The part that remains mostly bare. The part that makes the clustered regions feel like islands rather than a continuous landmass. That is what emptiness does at this scale. It becomes structural. It is no longer the absence of form. It is part of the form itself. And perhaps this is the real lesson of comparing sizes. At first, we think the goal is to understand how large the void is. But as we keep going, another truth quietly emerges. The size of the void is not only about its width, it is about what kind of things it can make seem small. A planet, of course. A solar system, naturally. A galaxy, surprisingly. A group of galaxies, almost effortlessly. Even a cluster, even a supercluster scale region, begin to feel less like ultimate structures and more like features around the edge of something larger. That is the power of the comparison. The Boötes Void does not merely exceed our usual scales. It rearranges them. It teaches the mind a new order of magnitude, not just in numbers, but in feeling. There is also a quieter comparison worth making, one that almost never appears first, but may be the most haunting. What is it like in terms of time? If light itself needs around 300 million years to cross the void, then crossing it at the speed of light would take longer than the entire existence of our species. Far longer. It would take longer than mammals have dominated the Earth. Longer than many chapters of life on this planet as we know it. Dinosaurs rose and vanished on timescales that begin to feel relevant beside such a crossing. That means the void is not only wider than familiar structures. It is older feeling than familiar history. Its scale pulls time into the comparison whether we invite it or not. If you set out from one side of the Boötes Void when the earliest primates were still unimaginably far in Earth's future, and traveled at light speed, you would only now be arriving at the other side. That is the kind of distance we are talking about. A distance so large that evolution itself becomes a unit of travel. And yet, despite all of this, the strange thing is that the void is not the whole universe. It is not even close. That may be the most humbling thought of all. After all these comparisons, after stretching the imagination until galaxies feel manageable and superclusters feel like map features, the Boötes Void still exists inside a much larger cosmos. It is a giant emptiness, yes, but it is one chamber in an architecture vastly greater than itself. The observable universe contains many voids, many filaments, many clusters, many walls of galaxies. The Boötes Void is extraordinary, but it is still local in the deepest cosmic sense. That realization does not diminish it, it deepens it, because it means the universe is not simply large. It is organized on scales that repeatedly exceed the mental containers we build for it. Each time we think we have reached the grand level, another larger level appears. Planet, star system, galaxy, group, cluster, supercluster, void, web, observable universe. And somewhere along the way, our language starts becoming less about things and more about patterns. That is the level the Boötes Void belongs to. Not object, but pattern. Not feature, but landscape. Not emptiness as a lack, but emptiness as an essential part of the cosmic design. If you were somehow able to travel through such a region, you would not experience it as a single dramatic sight. There would be no obvious wall marking your entrance. No sign hanging in darkness announcing that you had arrived. Instead, the scale would reveal itself through a kind of prolonged absence. Fewer galaxies. Greater separations. Longer stretches of black between islands of light. The realization would come slowly, then all at once. You would begin to understand that you were moving not through ordinary intergalactic space, but through one of the great quiet chambers of the universe. And maybe that is why numbers alone never quite do it justice. Because the Boötes Void is not just big, it is big in a lonely way. It is big in a way that changes the emotional texture of space. A galaxy can feel majestic. A cluster can feel grand. But a void feels different. It feels patient, reserved, almost indifferent to the existence of light. It allows a few galaxies, perhaps, but only enough to remind you how much darkness remains. If these slow journeys into scale help you relax, you can leave a quiet like, subscribe for more calm explorations of science and space, and, if you feel like it, share where you are listening from tonight. There is always something strangely comforting about imagining people in different rooms, different cities, and different time zones all pausing together to think about the same vast silence. And now that the size has begun to settle into place, another question naturally follows. If a void can be this large, this sparse, and this deeply woven into the structure of the universe, then why would such a region exist at all? Why would matter gather so richly in some places, while leaving behind chambers of such extraordinary emptiness in others? That is where the story turns next. Part 6. Why would a region this huge be so empty? At first, the idea almost sounds like a mistake. A region hundreds of millions of light years across, and yet so empty that astronomers speak of it in tones usually reserved for the unbelievable. It feels like the sort of thing the universe should not allow. After all, if space is so vast, and matter had so much room to spread out, why would one place end up with so little in it? Why would a region that large not at least gather a normal scattering of galaxies, stars, gas, and structure? Why would the universe leave behind something like the Boötes Void at all? It is a beautiful question, because hidden inside it is something even deeper. It is not just asking why one region is empty. It is asking how the universe organizes itself. How it decides, if that is even the right word, where matter gathers and where it does not. Why some places become rich and luminous, while others become silent and spare. And the answer, gentle as it is, begins very early. Long before there were galaxies, long before stars, long before planets, oceans, mountains, sleep, memory, or human beings looking up at the sky, the universe was much simpler than it is now. Hotter, denser, brighter, and more uniform. Not perfectly uniform, but close. Close enough that if you had somehow existed in those first moments and looked around, the cosmos might have seemed smooth. A great glowing sea of energy and matter, nearly even in every direction. Nearly. That word matters more than almost any other in this story. Because the universe did not begin in perfect balance. It began with tiny unvenuses, little differences in density so small they are almost hard to talk about without shrinking them into insignificance. But they were not insignificant. They were the seeds of everything that came later. Some regions contained ever so slightly more matter than average. Some contained ever so slightly less. That was enough. There is something quietly astonishing about that. The entire large-scale structure of the universe, every galaxy cluster, every filament of the cosmic web, every giant void, may trace back to tiny differences in the early universe so subtle that, at first glance, they would have looked almost like nothing at all. But gravity is patient. Gravity does not need drama. It does not need large beginnings. It only needs a difference, however small, and enough time to work on it. And time, the universe had in abundance. So imagine the early cosmos not as a finished design, but as a landscape with the faintest possible slopes. Barely there. So soft that at first you would not even notice them. Yet over enormous stretches of time, those shallow slopes begin to matter. Material starts to drift. Regions that were slightly denser pull in more matter, because they have slightly stronger gravity. Regions that were slightly emptier lose matter, because they have slightly less pull. This is the first key to understanding the giant voids. They did not become empty because something came along and scooped matter out of them. They became empty because, over billions of years, matter slowly migrated elsewhere. That distinction changes the feeling of it. A void is not a wound in the universe. It is not a place where the cosmos failed. It is more like a valley that formed because everything gradually rolled away from it, or perhaps more accurately, because everything rolled toward neighboring heights. If you imagine rain falling on a broad landscape, some droplets gather into streams, some streams join into rivers, and some regions are left drier simply because the water found easier paths elsewhere. The land was not punched open. It was sorted, guided, shaped by gentle differences and patient flow. The universe did something similar with matter. Only instead of rainwater, it was gas, dark matter, and the ingredients of future galaxies. Instead of hills and valleys made of earth, the landscape was made of density itself. And instead of happening over hours or days, it happened over billions of years. That is why the emptiness of a cosmic void is not as simple as it first appears. It is not merely blank. It is historical. It is the memory of where matter did not remain. And to really feel that history, it helps to introduce one more character into the story: dark matter. Dark matter is one of those ideas that sounds mysterious even before you understand what it means. It is called dark not because it is evil or shadowy in some dramatic sense, but because it does not shine. It does not glow, reflect, or emit light in the ways ordinary matter does. We do not see it directly. We infer it because of its gravity, because galaxies and clusters move as though much more mass is present than visible matter alone can explain. For this part of the story, what matters most is that dark matter helped build the scaffolding of the universe. Before ordinary matter gathered into stars and galaxies, dark matter had already begun forming the broad gravitational framework into which visible matter would eventually fall. You can think of it as an invisible skeleton, or perhaps a set of hidden riverbeds, quietly guiding where material was most likely to collect. That means the bright cosmic web we see today, the filaments lined with galaxies and the clusters glowing at their intersections, did not emerge from visible matter acting alone. Much of it formed because matter followed the deeper gravitational map laid down by dark matter. And where that map encouraged gathering, the web became richer. Where it did not, the emptiness deepened. So when we ask why a region this huge would be so empty, the answer is not that the universe randomly forgot to put galaxies there. It is that the underlying distribution of matter, both visible and invisible, evolved in a way that favored structure elsewhere. Some places became gathering points. Some became crossroads. Some became hubs. And in between, the quieter regions gradually lost the competition for material. That phrase may sound strange, the competition for material, but it captures something real. Not a conscious contest, of course. The universe does not decide. But gravity produces winners and losers all the same. A region that starts slightly denser has an advantage. It pulls more matter in. That extra matter increases its gravity further, which lets it pull in even more. Meanwhile, the underdense region next to it falls further behind. It loses mass, becomes emptier, and therefore has even less gravitational influence. This is one reason the universe today looks so structured. Tiny initial differences did not stay tiny. They amplified. Dense places became denser. Sparse places became sparser. And the voids are what the sparse places became after enough time had passed. There is something almost poetic in that. The universe is not only shaped by what accumulated, it is also shaped by what slowly drained away. And yet, there is another layer to it. Because emptiness, once it begins, has a tendency to grow. That may sound obvious, but in cosmology it has a very particular meaning. A void is not just a quiet place sitting passively inside the larger web. As matter flows toward denser regions around it, the void becomes more underdense relative to its surroundings. In a sense, it clears out further. Its boundaries, though not sharp like walls, become more noticeable in contrast. Small empty patches can stretch, press against neighboring ones, and in some cases merge into larger voids. So the giant voids we know today may not have started out as giant voids in the form we see now. They may have begun as smaller underdense regions, places slightly poorer in matter than average, which then expanded in influence as the surrounding cosmic web became more pronounced. Over time, some of these emptier regions could blend together, creating broader and broader chambers of relative emptiness. That idea helps explain why cosmic voids can become so enormous. The universe did not carve out one perfect bubble in a single dramatic act. It let a pattern of unevenness evolve. It allowed emptier regions to remain empty, then grow emptier, then connect with one another as the brighter structures around them became more sharply defined. If the cosmic web is like foam, then the voids are the bubbles inside it. And bubbles, once formed, do not need to be actively hollowed out one by one. They emerge because the surrounding material gathers into thin walls and edges, leaving the interiors open. That image is one of the most useful of all, because it reminds us that the bright parts of the universe and the empty parts are not two separate stories. They are the same story seen from opposite sides. A galaxy cluster is where matter gathered successfully. A void is where it did not. A filament is where the flow converged. A void is where the flow moved away. They define each other. And once you begin to think that way, the Boötes Void no longer seems like an exception to the universe. It seems like one of the most natural outcomes of the universe's deepest habit, which is this: to turn tiny differences into vast structures. Still, there is another quiet force at work here too: expansion. The universe is expanding everywhere. Space itself is stretching, carrying galaxies farther apart on the largest scales. In dense regions, gravity can resist that expansion enough to keep galaxies bound together in clusters or groups. But in emptier regions, where there is less matter and less gravity to hold things tightly, the sense of openness can grow even more pronounced. This does not mean voids are simply balloons being inflated in the ordinary sense. The physics is subtler than that. But as the universe expands, and as matter continues to collect more efficiently in denser places, the contrast between crowded and uncrowded regions becomes stronger. The web sharpens. The gaps feel larger. The universe becomes more legibly divided between structure and spaciousness. So by the time we arrive at the present-day cosmos, after billions of years of this patient sorting, we find a universe that looks less like a uniform mist and more like an enormous three-dimensional network. Bright threads, dense knots, wide hollow chambers. And inside those chambers, not absolute nothingness, but astonishing little. That is another important point to hold on to. Even the emptiest voids are usually not truly empty in the strictest sense. There may still be traces of gas. There may be dark matter, though less of it than average. There may be a few isolated galaxies, adrift in the quiet. Radiation still passes through. Space itself is still there. The laws of physics still apply. A void is a region of profound scarcity, not a cancellation of reality. That may sound like a technical correction, but it changes the atmosphere beautifully. Because it means a void is not dead in the total sense. It is lonely. It is sparse. It is a region where the normal social behavior of matter has thinned almost to disappearance, but not entirely. A few galaxies inside a giant void can make the emptiness even more haunting, not less. A handful of lights inside such a massive volume only emphasizes how much is missing. It turns the void into something the imagination can feel. Like seeing a few distant houses on a plain so vast that the silence between them becomes the real subject. And perhaps that is why the question of cause matters so much. When we ask why a place this huge is so empty, we are not just asking for a mechanism. We are asking how the universe came to allow that kind of loneliness. The answer, calm and unspectacular though it may be, is one of the most beautiful in science. It happened because the universe began almost smooth, but not quite. Because gravity took those small imperfections seriously. Because matter flowed toward matter. Because invisible dark matter helped shape the roads. Because empty places stayed empty long enough to become emptier. Because neighboring underdense regions could widen, connect, and become grand chambers in the larger cosmic design. Nothing supernatural. Nothing broken. Just the long patience of physics. And there is something very soothing about that. We often imagine the universe as dramatic, explosive, full of violent events and dazzling phenomena. And it is all of those things sometimes. But the existence of a giant void reminds us that some of the grandest structures in reality were made not by sudden catastrophe, but by slow sorting. By a billion years, and then another billion, and then another. By almost nothing happening in one place while structure flourished in another. A void is what time does to a slightly underfull beginning. That sentence may be the quiet heart of the whole idea. A void is what time does to a slightly underfull beginning. And if you let yourself sit with that for a moment, it begins to feel strangely intimate. Human lives are also shaped by accumulation and absence, by where energy gathers and where it drains, by what grows dense with memory and what becomes spacious and quiet. Not the same process, of course, but enough of an echo that the cosmos starts to feel less alien. The universe, too, is a place where patterns deepen with time. Some become bright, some become empty. Both become meaningful. There is one more reason astronomers care about this question. Giant voids are not just beautiful consequences of cosmic structure. They are clues. Because their size, shape, and distribution tell us something about the early universe, about how matter clumped, about how gravity behaved across cosmic history, and about how the universe expanded over time. In other words, voids are not just scenery. They are evidence. A bright cluster tells you where matter won. A void tells you where matter lost. Together, they reveal the rules of the game. And perhaps that is why these empty places feel so rich to think about. The less they contain, the more they say. They tell us that the universe was never perfectly uniform. They tell us that gravity is a patient sculptor. They tell us that visible galaxies are only part of a deeper structure. They tell us that emptiness itself has a history. And they tell us, in the softest possible way, that the universe is shaped just as much by what drifted away as by what remained. If this kind of calm exploration helps you settle in, you can leave a quiet like, subscribe for more slow journeys through science, and, if you feel like it, share where you're listening from tonight. There is something lovely about imagining these thoughts moving softly through late-night rooms around the world, while far above, the great dark architecture of the cosmos continues in silence. And now, once we understand why a void can become so empty, another question begins to open. Not how it formed, but what it would feel like to enter one. What would the sky look like inside a giant cosmic void? How lonely would the journey become? At what point would the absence stop feeling theoretical and start feeling personal? That is where the story drifts next. Part 7. What would it look like if you traveled through a cosmic void? There is a difference between knowing that something is empty and feeling that emptiness begin to surround you. From Earth, the universe does not look empty at all. Even on an ordinary night, the sky is filled with points of light. In a truly dark place, away from city glow, the Milky Way arches overhead like a pale river of dust and stars. If you use binoculars or a small telescope, more and more of the darkness starts to break apart into detail. Nebulae, clusters, faint galaxies. It gives the impression that the cosmos is crowded, or at least generously populated. That if you keep looking long enough, there will always be something else out there waiting to be found. But a giant cosmic void would change that feeling. Not suddenly. That is important. The universe rarely changes all at once. Most of the time, it changes slowly enough that the mind adjusts as it goes. A journey into a void would not begin with a wall, a gate, or a signpost. You would not cross some glowing border and watch the stars disappear in a single dramatic moment. Instead, the change would come as a thinning, a gradual quieting, a slow and unsettling subtraction. At first, you might not even notice it. Imagine that our journey begins far from Earth, already beyond the familiar territory of our galaxy, beyond the local group, beyond the dense neighborhoods where galaxies still gather in recognizable company. We are drifting through the larger web of the universe now, where galaxies no longer appear as bright spirals in the sky, but as distant islands of light suspended in a dark and almost depthless ocean. In these outer regions, the sky would already look very different from the one above Earth. There would be no bright blue atmosphere, no twinkling caused by air, no comfortable pattern of constellations that generations of human beings have memorized. Constellations only make sense from where we happen to live. Move far enough through the cosmos, and the familiar shapes break apart. Orion dissolves. Ursa Major becomes meaningless. The stars rearrange themselves. The sky loses its inherited map. That alone would feel strange. But the true strangeness would come later, as the denser structures around you begin to fall away. A filament of galaxies, seen from a great distance, might resemble a sparse chain of embers strung across a black plain. Around it there would be more darkness than light already, yet still enough surrounding structure to reassure you that you are inside a connected universe. There are still destinations, still nearby systems, still a sense that if you keep going, something will appear. Then the chain begins to thin. A few galaxies remain behind you, a few ahead. The side views grow emptier. The gaps between meaningful objects become larger and harder to emotionally measure. One by one, the nearby islands of light begin to slip so far apart that your sense of the sky changes. It becomes less like a scene and more like an absence. This is the beginning of what it would feel like to enter a void. The unsettling part is not darkness by itself. Space is dark almost everywhere. The unsettling part is relational darkness, darkness defined by the increasing lack of nearby structure. It is the growing realization that the universe around you is no longer merely vast, but sparsely inhabited on a scale that starts to feel personal. If you had instruments, they would notice it before your eyes fully could. They would tell you that the density of galaxies has dropped, that the nearest large systems are growing more distant, that the map of your surroundings no longer resembles a web with nearby strands, but a widening chamber with only a few faint markers near its edges. Without those instruments, your eyes alone would struggle to understand what had changed. That is another eerie part of traveling through a void. The human mind wants emptiness to look dramatic. It wants a visual payoff. But a cosmic void would be more subtle than that. From a single location inside it, the sky would still contain stars if you were inside a galaxy. Your own local world would still glow with its own sun or suns. Your home galaxy, if you had one, would still hang in the sky as the dominant structure of your night. The emptiness would not erase your immediate surroundings. It would erase the usual richness beyond them. That is a much more haunting kind of loneliness. From Earth, if our atmosphere vanished and we could see the broader universe with enough clarity, the sky would still be full of evidence that we live in a populated cosmic region. We have neighboring galaxies. We inhabit a universe whose local density, while not extreme, is generous enough to reveal that we are part of a much larger family. But deep inside a giant void, the nearest major galaxy might be tens of millions of light years away. So far, in fact, that it would not reveal itself as an obvious feature to the naked eye at all. You could live your whole life beneath such a sky and feel, quite naturally, that your own galaxy was the whole of creation. That possibility has fascinated astronomers for years. If the Milky Way had formed in the middle of a giant void like Boötes, humanity may have taken far longer to discover that other galaxies existed at all. Not because we would have been less intelligent, but because the evidence would have been harder to see. The universe would have looked lonelier from the start. Try to sit with that for a moment. History itself would feel different. Ancient mythologies, philosophies, and religions all formed under a sky that still offered enough richness for wonder to multiply outward. But in a much emptier cosmic neighborhood, the imagination might have developed with a stronger sense of isolation. The larger universe would not just be unknown. It would be plausibly absent. Your galaxy might seem like everything. And that is perhaps the most intimate way to understand what a void feels like. Not merely empty space around you, but a reduction in cosmic company so severe that it changes what a civilization could reasonably believe about reality. Now let us continue the journey. We move deeper into the void. Behind us, the last denser structures have faded into distance. Ahead, there is no visible wall, because voids do not have walls in the ordinary sense. Their boundaries are defined by contrast, not by barriers. Yet you can feel, in a metaphorical way, that you have crossed one. The surrounding universe no longer feels socially connected. It feels sparse. You are in a region where the bright architecture of the cosmic web has retreated. What does the sky look like now? If you are traveling in the open space between galaxies, it would be close to absolute blackness. Not the soft darkness of Earth's night, which is washed with atmosphere, moonlight, and the glow of scattered stars, but a darkness that feels almost like a substance. Thick, velvety, and nearly without texture. The few visible galaxies would not look like the bright spirals shown in popular illustrations. At great distances, most galaxies are faint smudges even through telescopes. To the unaided eye, many would disappear completely. That means the sky of intergalactic travel inside a void would not be decorated with grand scenery. It would be mostly black, with perhaps a few dim reminders that structure still exists somewhere far away. And blackness on that scale is not passive. It changes your sense of position. On Earth, even darkness has context. A horizon, trees, wind, the sound of your own breathing in a room. In space, between galaxies, especially inside a void, there is almost no context at all. No up, no down, no nearby landmark to stabilize the imagination. Your direction matters mathematically, but emotionally, every direction begins to feel the same. That may be one reason a journey through a void feels so powerful as an image. It strips the universe down to almost pure scale. It removes clutter. It removes the comforting illusion that the cosmos is full everywhere you look. It leaves you with something simpler and stranger, immense volume with almost nothing in it. And yet, there would still be beauty. Not the crowded beauty of nebulae and star fields, but a quieter, more severe beauty. The beauty of proportion, of silence, of seeing a few galaxies, perhaps, strung out like tiny lanterns across distances so huge that each one feels less like a neighbor and more like a memory. If your ship, or whatever carried you, had a window, the most dramatic moments might not come from looking outward at all. They might come from looking backward. because only by looking behind you would you see what you had left. A denser wall of galaxies, perhaps faint and distant now, marking one of the filaments or sheets that bordered the void. It might resemble a shoreline seen from far out at sea, except that this shoreline is made of galaxy clusters and superclusters, stretched across a cosmic horizon. That image matters. It reminds us that a void is not an independent kingdom. It is part of the same larger structure. The emptiness only makes sense because there are richer regions around it. Like a valley only makes sense because there are hills beyond it. The void does not float alone. It is framed by the universe's brighter architecture. Still, once you drift deep enough into it, that framing would start to disappear. The surrounding walls of structure would retreat into such great distance that even they would begin to lose their authority over the sky. The emptiness would no longer feel bordered. It would feel total. This is the point where the imagination tends to become uneasy. Not because anything dangerous is happening in the dramatic sense. A cosmic void is not filled with monsters. There are no storms of teeth or supernatural threats waiting in it. The danger is subtler. It is existential. It is the feeling that you have wandered into a region where the universe has become almost indifferent to the existence of visible matter. That thought can sound frightening, but in a sleep story like this, it can also become strangely peaceful. Because a void is not hostile. It is quiet. It asks very little of you. It offers no spectacle demanding your attention. No violent choreography of constant events. It is one of the few places in the universe where the scale of silence becomes the main subject. And perhaps that is why it lends itself so naturally to calm reflection. A dense galaxy cluster is magnificent, but it is busy. A supernova is brilliant, but it is brief and intense. A void offers something more like stillness. Not stillness because nothing exists there, but stillness because so little interrupts the vast open intervals between things. Now imagine, just for a moment, that you are not merely passing through the void, but living inside one of its rare galaxies. This may be the most evocative version of the thought experiment, because it gives the emptiness a home. You step outside at night onto the surface of a planet circling an ordinary star in one of the few galaxies adrift inside a giant void. The stars of your own galaxy still fill the sky in their usual way. There may be a bright band of local starlight above you, perhaps something like a version of our Milky Way arching overhead. Your immediate universe does not feel empty at all. It feels richly populated with nearby suns, dust lanes, and the quiet grandeur of your own galactic home. But beyond that, there is almost nothing. No bright Andromeda-like companion visible to the naked eye. No obvious neighboring island of stars. No reassuring evidence that the sky contains many other galaxies just beyond your own. If your civilization is young, it may not even suspect that the broader universe is richly structured. It may feel alone for a very long time. That sky would be one of the loneliest skies imaginable. And the loneliness would not be emotional only. It would be observational, scientific, civilizational. The very history of discovery would be delayed by the simple fact that the universe around you does not advertise its abundance. There is something deeply humbling about that. Knowledge depends not only on intelligence, but on setting. We know what we know partly because of where we are. Now imagine leaving that galaxy too, and returning to open intergalactic space. At this point, the journey becomes less about scenery and more about time. Because crossing a giant void is not a short trip. It is not even a long trip in the ordinary sense. It is a trip that redefines what long means. Light itself would need hundreds of millions of years to cross something like the Boötes Void. Any slower traveler would be committing not to a voyage, but to a chapter of cosmic history. This affects the visual feeling of the journey more than people sometimes realize. When objects are so far apart, movement stops feeling intuitive. On Earth, when you walk through a landscape, nearby objects shift around you quickly. Trees pass. Hills change angle. Streets unfold. In deep space, especially inside a void, parallax becomes painfully slow. The sky would appear almost motionless. You could travel for extraordinary stretches of time and see only the gentlest rearrangement of distant lights. That stillness would be profound. It would feel as if the universe had ceased to behave like a place and started behaving like a frozen thought. And yet, over immense durations, there would be change. Galaxies at the far edges would slowly alter position. Some would redshift further as the universe expanded. The bordering walls of structure might seem to recede. The void, in a way, would feel not only empty but patient. It would not resist your presence. It would simply outlast your expectations. Maybe that is the most accurate emotional description of traveling through one. A journey through a giant cosmic void would feel patient. Patient darkness. Patient distance. Patient silence. Not dramatic enough to terrify in the usual cinematic way, but large enough to slowly undo your instinct that the universe should always give you something nearby to hold on to. And in that slow undoing, something else might happen. Your attention might begin to turn inward. Because when the outside world offers almost no new interruptions, the mind does what it often does in quiet places. It starts to notice itself. That is true in a dark room. It is true on a long night walk. It is true near the ocean. And it would be true, perhaps more than anywhere else, inside a cosmic void. You would begin with astronomy, but you might end with philosophy. Not because the void demands that, but because immense emptiness has a way of turning observation into reflection. It asks questions without speaking them. How much company do we need to feel connected to the universe? How much of our sense of meaning depends on being surrounded by visible abundance? Would the cosmos feel less beautiful if it were lonelier, or simply stranger? These are the sorts of thoughts a void invites. And perhaps that is why the idea stays with people. Not because it is the loudest structure in the universe, but because it is one of the quietest. And quiet things often linger longer. If this slow drift through the universe is helping you relax tonight, you can leave a quiet like, subscribe for more calm journeys into science, and, if you feel like it, share where you're listening from. It is always comforting to imagine these thoughts traveling softly through homes and headphones in different corners of the world, while the real cosmos stretches out in patient silence above us all. And now that we have felt what it might be like to move through one of these immense empty chambers, another question begins to rise. If a void feels so empty, is it really empty at all? Or are there still things hidden in that darkness, so faint and thinly spread that emptiness is only the first impression? Part 8, are voids truly empty, or is something still there? The first answer is no. A cosmic void is not truly empty. And somehow, that makes it even stranger. Because absolute nothingness is almost too simple for the mind. If a void were completely empty, with no matter, no light, no particles, no radiation, no trace of structure at all, then at least the idea would be clean. Severe, perhaps, but clean. A blank page. A perfect absence. Something almost mathematical. But the real universe is rarely that tidy. What we call a void is not pure nothing. It is something subtler, quieter, and in many ways more haunting than that. A void is a place where there is astonishingly little, but not absolutely none. A place where the universe has thinned itself almost to silence, yet still leaves behind faint traces of its presence. A few galaxies. A whisper of gas. Invisible scaffolding. Ancient light drifting through. Maybe even the quietest leftovers of the early universe, still crossing those dark distances without ever stopping. It is tempting to imagine emptiness as a final state, as if once a region becomes empty enough, it reaches a kind of perfect stillness. But that is not how cosmic voids work. They are not erased regions. They are underfilled ones. That word matters. Underfilled. Not cancelled. Not deleted. Just far, far below what the rest of the cosmic web might lead you to expect. That difference is the whole story. Because it means a void is not the opposite of the universe. It is one of the universe's gentlest expressions. Picture a city just before dawn. Most of the windows are dark. The streets are nearly silent. The crowds have vanished. Yet the city is not empty. Somewhere a light glows in a distant apartment. Somewhere a train hums through the darkness. Somewhere a person is awake, boiling water in a kitchen, looking out at the quiet. The city feels empty only because its usual density of life has fallen away. A cosmic void is like that, but on scales so large that ordinary comparison starts to fail. When astronomers map a giant void, they are not finding a literal hole in reality. They are finding a region in which the density of galaxies is far lower than average. That means there may still be a few galaxies drifting inside it, even though the void as a whole remains profoundly sparse. The Boötes Void, for example, became famous not because it contains nothing at all, but because it contains so little compared to the huge volume it occupies. That distinction matters because it turns the void from a fantasy of perfect nothingness into something more physical, more believable, and, in a way, more atmospheric. A handful of galaxies inside a vast dark region can feel lonelier than total blankness. Total blankness is abstract. A few scattered galaxies are personal. They give the emptiness scale. They become tiny points of reference inside a darkness so large that the mind cannot help but feel the spaces between them. If you were somehow drifting through such a void, one of the strangest realizations would be this: the emptiness is real, but it is not complete. There are still islands out there, only so few, and so widely separated, that the region feels abandoned rather than vacant. And galaxies are only the first layer of what remains. Because even where galaxies are scarce, space itself is not bare. There is still matter spread thinly through the darkness, especially in the form of gas. Not thick clouds like the kind we imagine in nebulae, and not anything remotely like air. The gas in a cosmic void would be fantastically tenuous, so diffuse that any ordinary human sense of emptiness would still call it nothing. But at the level of physics, it matters. Hydrogen atoms, ionized particles, faint plasma, the residue of the larger cosmic medium, all of it stretched so thin that even the word thin begins to feel too heavy. That may sound like a technical detail, but it changes the mood beautifully. A void is not a hollow carved out of existence. It is more like a region where matter has become whisper-like. That is a very different kind of emptiness. It means there is still a medium, however faint, for reality to continue expressing itself. Radiation passes through. Gravity still reaches across it. Particles still drift. Time still unfolds there, or at least we experience it unfolding there. The laws of the universe do not pause inside a void. They continue calmly, only with far less material to work on. And there is another invisible ingredient that matters even more than the gas: dark matter. It sounds mysterious every time it is named, but in this context it helps to think of it in the simplest possible way. Dark matter is matter we do not see directly, but whose gravity helps shape the universe. It does not glow. It does not shine in the dark. It does not make a void look fuller to the eye. But that does not mean it is absent. Even inside cosmic voids, dark matter is not expected to vanish entirely. There is simply less of it there than in the denser parts of the web. That is such an important point. A void is not only defined by having fewer visible galaxies. It is also part of a deeper landscape in which the total mass, including the invisible kind, is lower than average. The hidden scaffolding is thinner there. The gravitational field is gentler. The great cosmic traffic that fed clusters and filaments passed largely around these regions, not through them. So even the invisible structure of the universe reflects the same quietness. In a way, the void is empty all the way down, but never completely. That may be the most accurate sentence of all. Empty all the way down, but never completely. There are still the few galaxies. Still the faint gas. Still the thinner presence of dark matter. And beyond that, there is light. Not the bright, local light of nearby stars necessarily, but older light. More diffuse light. The kind of light that does not belong to any one object, but to the history of the cosmos itself. One of the most remarkable things about space, even the emptiest space, is that it is flooded with ancient radiation. Everywhere in the universe there is the faint glow of the cosmic microwave background, the leftover light from the early universe, stretched by expansion into microwaves so cold and gentle that we do not feel it at all. It fills all of space. Not only clusters. Not only galaxies. Even the great voids are bathed in it. So a void is not truly dark in the absolute sense. It is immersed in the afterglow of creation, though that glow is far beyond human vision. That thought changes the feeling of the darkness. What looks empty is still full of history. Even in the loneliest chamber of the cosmic web, the early universe has not stopped speaking. Its voice is simply too soft, and too old, for human senses to hear directly. There is something deeply soothing about that. The void is not cut off from the story of the universe. It is still inside the same great memory. The same Big Bang that eventually gave rise to stars and planets also filled even the emptiest regions with a faint, nearly uniform bath of ancient light. And the cosmic microwave background is not the only traveler passing through. Photons from distant galaxies still cross the darkness. High-energy particles from violent events elsewhere may pass through. Neutrinos, those ghostly little particles that almost never interact with anything, stream across the universe in immense numbers, barely noticing matter at all. Gravitational influence still stretches across the void, connecting it to the denser architecture beyond. In other words, even where matter is rare, motion is not absent. The void is not sealed. It is crossed continually by quiet messengers. This is what makes the question of emptiness so beautiful in astronomy. The more closely you examine nothing, the more it turns out to contain. Not enough to make the void feel crowded, not enough to break its character, but enough to remind you that perfect nothingness is extremely hard to find in a real universe. Reality prefers gradients. Thinness rather than total absence. Quiet rather than pure silence. Even the galaxies that do exist inside voids are fascinating for this reason. A galaxy in a dense cluster lives a very social life, cosmically speaking. It is pulled, disturbed, surrounded, and influenced by many neighbors. Collisions and close encounters are more common. Gas can be stripped away. Motion is more chaotic. But a void galaxy grows up in a very different setting. It may spend billions of years in relative isolation, evolving with less interference from nearby systems. That solitude makes such galaxies scientifically interesting. They are not better or worse than cluster galaxies. Just different, shaped by a quieter neighborhood. That is another reason a void feels less like a blank and more like an environment. It is not just a place with less stuff. It is a place where the remaining stuff lives differently. A lonely galaxy in a void may keep more of its gas. It may form stars under calmer conditions. Its history may be less interrupted by cosmic traffic. If a civilization ever arose in such a galaxy, their night sky, their astronomy, perhaps even their philosophy, would be shaped by this solitude. The universe would appear less social. The large cosmic web might take longer to infer. Their sense of being at the center of everything might survive much longer than ours did. And again, that does not happen because the void is truly empty. It happens because it is empty enough. That phrase is worth lingering on. Not completely empty. Empty enough. Empty enough to delay discovery. Empty enough to change perspective. Empty enough to turn the surrounding darkness into a major feature of existence. Empty enough to feel unlike almost any other place in the cosmos. This is often how nature works. It rarely deals in absolutes. The sea is never perfectly still, but it can be still enough to mirror the moon. A forest is never completely silent, but it can be silent enough that your own breathing suddenly sounds loud. A cosmic void is never completely empty, but it can be empty enough that the few remaining things inside it only deepen the sense of isolation. There is also another subtle point here, one that makes voids even more interesting. Because the remaining matter inside a void is not necessarily spread out evenly. The few galaxies there may trace faint filaments, thin bridges, or little clumps, like the last remnants of a once broader structure or the quiet outline of the deeper gravitational landscape. So even within emptiness, there can still be pattern. Not much pattern, not rich pattern, but enough to suggest that the void is not a featureless box. It has texture, only texture at an almost unbearable scale. That is why a void cannot really be understood as a giant empty sphere floating in blackness. It is more like a broad underdense basin in the cosmic web. Its boundaries are fuzzy. Its interior is not uniform in the strictest sense. Its emptiness varies from place to place. Some corners may be more barren. Some thin strands may still pass through. Some lonely galaxies may cluster gently in one region and disappear almost entirely in another. The overall feeling remains one of vast scarcity, but the details are more nuanced than the word void suggests. This is, perhaps, a good place to say something a little philosophical. Human beings often imagine emptiness as failure. An empty room, an empty page, an empty calendar, something missing. Something not yet filled. But the universe does not seem to think that way. In the universe, emptiness is not failure. It is structure. It is one of the ways reality arranges itself. The bright and crowded places are not the whole point. The spacious, quiet places are just as much a part of the design. That changes how a cosmic void feels. It is not a neglected corner of the universe. It is one of the main ways the universe makes room for itself. And maybe that is why the question, is it truly empty, leads to such a satisfying answer. Because the answer is both no and almost. No, in the strict sense, because there is still matter, still radiation, still gravity, still history, still the faint leftovers of cosmic structure. But also almost, in the emotional sense, because compared to the denser parts of the universe, the void is still one of the loneliest, quietest, most underfilled regions imaginable. That balance is what makes it real. If it were completely empty, it might feel too abstract to touch with the imagination. If it were much fuller, it would lose its haunting power. Instead, it occupies a perfect middle ground between something and almost nothing. And that middle ground is where some of science's most interesting truths live. Because voids teach us that reality is often most revealing at low volume. When the noise of dense structure fades, the background becomes easier to study. The emptiest places can become clean laboratories for understanding how the universe expands, how matter is distributed, how gravity behaves over enormous scales, and how the great web of structure emerged from the early cosmos. In crowded places, too many processes overlap. In quieter places, some of the deeper rules become easier to notice. So the void is not merely a dramatic curiosity. It is informative silence. A place where the lack of clutter becomes a source of knowledge. And that may be one of the most beautiful ideas in all of cosmology. The emptiest places in the universe can still tell us something profound, perhaps precisely because they contain so little. They strip the scene down. They reduce the distractions. They let us study the architecture more clearly. It is a little like walking through a great museum after closing time. During the day, crowds fill the rooms. Voices echo. Movement distracts the eye. But late at night, when everything is still, the space itself becomes easier to feel. The proportions become clear. The arrangement of the halls makes sense. In a similar way, a void lets astronomers feel the architecture of the universe, because there is less in the way. And perhaps that is also why the subject fits so naturally into the mood of deep sleep. A void is not loud science. It is patient science. It is the science of restraint, of asking how little can remain before a region starts to feel like almost nothing at all. and then discovering that even almost nothing is still rich with meaning. If this kind of calm exploration is helping you unwind tonight, you can leave a quiet like, subscribe for more slow journeys through science, and, if you feel like it, share where you're listening from. It is always comforting to imagine these thoughts drifting softly through late-night rooms around the world, while the real universe continues in its immense, patient silence. And now, once we understand that a cosmic void is not truly empty, another question begins to open. If these quiet regions still contain traces of matter, light, and structure, then what do they reveal about the larger universe itself? What can these vast empty chambers teach us about cosmic history, about the shape of the web, and about how reality became arranged the way it is? That is where the journey moves next. Part 9. What cosmic voids teach us about the shape and history of the universe? Sometimes the quietest places tell the biggest stories. That may be the strangest lesson of all. If you had to choose the best place to understand the universe, you might assume it would be somewhere bright, somewhere crowded, a galaxy cluster packed with motion, collisions, radiation, and matter. A place where everything is happening at once. That would seem logical. If you want to understand reality, go where reality is loudest. But the universe does not always reveal itself that way. Sometimes the clearest truth appears where almost nothing is happening. That is what makes cosmic voids so important. They are not only eerie. They are not only beautiful in a severe, quiet way. They are also revealing. These great underfilled regions help astronomers understand how the universe is shaped, how it grew, how matter moved, how gravity sculpted the cosmos, and how the largest pattern of all slowly emerged from the early universe. In a strange way, voids are not empty pages. They are outlines. They show us the shape of everything else. To understand that, it helps to step back and remember what the universe might have looked like long ago, before galaxies filled it with structure. The early universe was not arranged into the giant web we see today. There were no great walls of galaxies yet, no sprawling filaments, no clusters piled high with matter, no giant voids opening like quiet chambers between them. There was only an expanding young cosmos, incredibly hot and dense at first, then cooling, smoothing, and beginning its long transformation. On the largest scales, it was remarkably uniform. Not perfectly uniform, but close enough that the later richness of structure had not yet appeared. That is one of the most important facts behind everything we are talking about. The universe did not start out looking obviously shaped. It became shaped. And the voids are part of how we know that transformation really happened. When astronomers map the modern universe and see this immense foam-like pattern of filaments and empty regions, they are looking at the result of billions of years of cosmic sorting. Matter did not remain where it began. It drifted. It gathered. It thickened in some places and thinned in others. Dense regions pulled in more mass. Underdense regions lost it. Over time, the contrast sharpened until the universe took on its present large-scale form. So when we study a void, we are not merely studying emptiness. We are studying evidence of movement. A void tells us that matter once had a chance to be there, but ended up elsewhere. That is a very deep kind of information. It means the shape of the universe is not random. It is historical. It carries memory. The giant empty regions and the bright crowded regions belong to one long story of growth and migration. The voids are where matter became scarce because gravity encouraged matter to collect more efficiently somewhere else. This is why the overall shape of the cosmos is often described as a cosmic web. That word, web, matters because it implies relationship. A web is not just a pile of threads. It is a pattern made of connections and gaps. The bright parts only make sense because the open spaces around them exist too. In the same way, the universe is not just a collection of galaxies. It is a network of filaments, clusters, walls, and voids, all defining one another. A filament is easier to see because it glows with galaxies. A void is harder to see because it is marked by absence. But both are equally important to the structure. In fact, if you want to understand the shape of the universe on the grandest scales, voids may be among the cleanest clues you can ask for. A crowded cluster is full of complicated processes. Galaxies collide. Gas heats up. Black holes flare. Star formation turns on and off. Everything is dynamic and noisy. Important, yes, but messy. A void, by contrast, is simpler. There is less clutter, less chaos, less local confusion. That makes it easier, in some ways, to study the deeper geometry of the cosmos. It is a little like trying to understand the layout of a city. If you stand in the busiest marketplace, you will learn a lot about the life of the city. You will hear voices, see traffic, notice the details of daily existence. But it may be hard to understand the city's overall plan from there. Too much is happening at once. Step onto a hill outside the center, though, and suddenly the structure becomes clearer. Roads, districts, open spaces, boundaries, patterns. Voids do something like that for cosmology. They quiet the local noise enough that the broader design can come into view. And that design is one of the most astonishing things science has ever uncovered. Because the universe is not merely full of objects. It is arranged. That sentence sounds simple, but it carries enormous weight. It means the cosmos has large-scale texture. It has geography. It has structure far beyond the level of individual galaxies. The brightest things in astronomy, stars and galaxies, are not spread through space like random glitter. They gather along great cosmic lines and surfaces, leaving behind wide underdense basins. Once you see that pattern, you cannot unsee it. The universe stops feeling like a scattered collection and starts feeling like architecture. Voids are part of the proof. They tell us that the universe is shaped not only by what formed, but by what was left behind. And from there, another lesson begins to emerge. Voids help us understand time. Not time in the familiar human sense of clocks and calendars, but cosmic time. The long unfolding of the universe from its simpler beginnings into its present complexity. A void is not just a static place. It is the result of evolution. It exists because the universe has been changing for billions of years. Matter flowed outward from underdense regions toward denser ones. Small voids expanded and sometimes merged. The web sharpened. The contrast between crowded and uncrowded space increased. In other words, voids are old. Not old merely because they have existed for a long time, but old because they embody a long process. They are the visible outcome of deep time working patiently on tiny early differences. That is one of the reasons astronomers care so much about them. If you can understand the size, shape, and distribution of voids, you gain insight into how quickly structure formed, how strongly matter clumped, and how the universe changed as it aged. The voids are like fossil impressions of cosmic growth, not fossils of creatures, but fossils of density. Fossils of where matter did and did not go. And when you think of them that way, they begin to feel less like empty chambers and more like records. Records of the early universe. Records of gravity's patience. Records of how simplicity turned into complexity. There is something deeply satisfying about that. It means the universe keeps a memory of its own youth, not in words, not in images, but in structure. The voids are part of that memory. They also teach us something about balance. The large-scale universe is shaped by a tension between gathering and expansion. Gravity pulls matter together. At the same time, the universe itself expands. In denser regions, gravity can win strongly enough to build galaxies, clusters, and larger structures. In emptier regions, there is less material to resist the overall stretching of the cosmos. That makes voids special places for understanding the broader expansion of the universe. This is where the story becomes especially interesting. Because one of the biggest mysteries in modern cosmology is dark energy, the name we give to the process or property causing the expansion of the universe to accelerate. We do not fully understand it. It is one of the deepest open questions in science. And yet voids may help us study it more clearly. Why? Because in emptier regions, the effects of the broader cosmic expansion can stand out more cleanly. There is less local clutter from dense structure, less gravitational chaos from crowded environments. A void is not free of physics, of course. It is full of physics, but it can be quieter physics, cleaner physics, the kind that helps scientists test how the universe expands and how matter behaves on enormous scales. That is such a beautiful irony. The emptiest places may help us understand one of the biggest things the universe is doing. And it does not stop there. Voids also help astronomers test gravity itself. That idea can feel a little abstract, so let us slow it down. Gravity is the great sculptor of cosmic structure. It is what gathered matter into galaxies and clusters in the first place. But when scientists ask whether gravity behaves exactly the way current theory predicts across all scales, they need places where the signal is easier to read. Dense places are complicated. Too many processes overlap. Voids, by contrast, can act like cleaner laboratories. If the shapes and behaviors of voids differ from what our best models predict, that could hint that something deeper about cosmic physics still needs to be understood. So once again, emptiness becomes useful. Not because it contains nothing, but because it contains less interference. This is why some astronomers speak of voids almost as if they are measuring devices built by the universe itself. Their forms, their boundaries, their evolution, and their relation to the cosmic web all carry information about the underlying rules. That makes them quiet, but not passive. Silent, but not blank. There is another lesson too, one that feels almost philosophical. Voids remind us that most of the universe, by volume, is not where the stars are. This is easy to forget. Human beings are creatures of brightness. We orient ourselves around light. We build stories around the visible. We admire the blazing, the crowded, the energetic. In astronomy too, the eye is naturally drawn to galaxies, nebulae, quasars, and clusters. These are the places that photograph well, the places that feel rich and eventful. But the universe does not distribute volume the way our attention does. By volume, the quieter regions dominate. That means the bright regions, for all their magnificence, are in some sense the exception. The rule is spaciousness. The rule is separation. The rule is great intervals of relative emptiness, with the luminous structures strung delicately around them. This changes the emotional picture of the cosmos. It suggests that the universe is not mainly a crowded place with a few gaps. It is mainly a spacious place with a few concentrations. The filaments and clusters are stunning, yes, but they are like intricate lace stretched over a much larger openness. Once you begin to see that, the universe feels less like a city and more like a landscape of islands. That realization can be strangely calming. It means emptiness is not an accident. It is the dominant condition. And yet, even within that, another truth stands beside it. The small bright islands matter enormously, because that is where complexity happens. That is where stars form, planets gather, chemistry deepens, and life, perhaps, occasionally emerges. So the universe holds a remarkable balance. Vast emptiness by volume, and extraordinary richness concentrated into narrow regions. Silence almost everywhere, and intricate activity in a delicate web. The voids help us see both at once. They make the bright regions feel brighter by contrast. They make the web feel more improbable. They show us just how special a galaxy really is. That may be one of their most human lessons. When you understand cosmic voids, you understand more clearly that the Milky Way is not just one object among many. It is one of the fortunate dense regions in a universe where so much volume contains so little. Our existence depends on the fact that matter gathered here rather than draining away. The stars, Planets, oceans, and living cells that eventually led to you are all products of a region where the universe became locally rich instead of locally empty. A void teaches that by contrast. It teaches gratitude through scale. It teaches that our cosmic address matters. And then there is perhaps the most elegant lesson of all. Voids help confirm that small beginnings can grow into immense consequences. This may sound almost like philosophy, but it is also physics. The giant structures of the modern cosmos were not present at the start in their finished form. They emerged from tiny fluctuations in the early universe. Slightly denser here, slightly less dense there, almost nothing, at first glance. And yet, given time, those tiny imbalances turned into galaxies, clusters, filaments, and giant empty chambers. The whole large-scale universe grew from faint irregularities that gravity patiently amplified. That is an extraordinary story. It means the universe we know, with all its dramatic contrast, came from subtle beginnings. Voids make that visible because they are among the clearest large-scale consequences of those tiny early differences. They show what happens when slightly less is given billions of years to become immensely emptier. They are the quiet side of the same process that gave us the great bright cities of the cosmos. In that sense, a void is not just a place. It is a long argument made by time. An argument that says small differences matter. An argument that says the universe remembers its beginnings. An argument that says structure is history made visible. This is why the study of cosmic voids has become so important. Not because voids are dramatic in the usual way, but because they are precise in a deeper way. They carry information about the early universe, the growth of structure, the strength of gravity, the nature of expansion, and the hidden scaffolding of matter beneath what we can see. They are quiet, but scientifically eloquent. And still, even after all of that, they remain emotionally powerful too. Because to think about a void is to think about a region where almost nothing interrupted the darkness for hundreds of millions of light years. A region so sparse that a civilization inside it might have felt cosmically alone. A region that, in its silence, helps explain the grand design of everything around it. That combination is rare. Scientific value and emotional atmosphere. A place that can help measure the universe, and also make you feel its loneliness. A structure that teaches cosmology, and also invites reflection. Maybe that is why voids stay with people. They do not overwhelm the mind with motion. They do not dazzle it with color. They do something quieter. They widen it. They make the cosmos feel less like a collection of objects and more like a living pattern of presence and absence, abundance and restraint, light and spaciousness. And once you understand that, the universe is no longer just a star-filled stage. It becomes a web suspended over silence. If this kind of slow exploration helps you relax, you can leave a quiet like, subscribe for more calm journeys through science, and, if you feel like it, share where you're listening from tonight. It is always comforting to imagine these thoughts drifting softly through different rooms and different time zones, while the real universe stretches out above all of us in patient darkness. And now one final question begins to open. If cosmic voids have already taught us so much about the shape and history of the universe, then are we finished finding them? Or could there be even larger, even lonelier, even more astonishing voids still waiting in the dark, beyond the limits of the maps we have made so far? Part 10. Could there be even larger voids still waiting to be found? The most unsettling possibility is not that the universe contains a giant void. It is that the giant void we know may not be the end of the story. Because once you have learned that the cosmos can produce regions of such enormous emptiness, regions so wide that light would need hundreds of millions of years just to cross them, a new question begins to follow you into the silence. Not what the Boötes Void is, not how it formed, not even what it would feel like to drift through it, but something softer, and somehow even more haunting. What if there are larger ones? What if the greatest empty chambers of the universe are still beyond the edges of our maps, or half hidden inside data we have not finished interpreting, or waiting for better instruments and deeper surveys to reveal them with full clarity? That is the final door this subject opens. And the honest answer is not a dramatic yes or no. It is something calmer than that. It is that the universe is still being mapped, still being measured, still being understood. And because of that, the largest void ever discovered is not the kind of sentence that closes a case forever. It is more like a marker placed in a continuing journey, a name attached to what we know for now, while the larger darkness keeps its own counsel. That is one of the most beautiful things about astronomy. It does not pretend that the current map is the final map. It knows better. Human beings have only recently become capable of surveying the universe in 3 dimensions on truly immense scales. For most of our history, the night sky was just a flat tapestry above us. Then came better telescopes, better detectors, better ways of measuring distance, better ways of tracing how galaxies are distributed across space and time. And as our view improved, the universe changed shape before our eyes. It became a web, a lattice of crowded filaments and great hollow chambers. The Boötes Void emerged from that expanding picture not because it suddenly formed, but because we finally learned how to see what had been there all along. That should make us humble. If a structure that large could exist unnoticed until modern surveying techniques reached a certain maturity, then it is entirely reasonable to wonder what else remains incomplete in our maps. Not because science is weak, but because the universe is staggeringly large and our vantage point is necessarily limited. We see from one small galaxy, from one small planet, through one moving moment in cosmic history. Everything we learn is filtered through that narrow window. And yet what we have learned already is enough to make the question unavoidable. Could there be larger voids than Boötes? Possibly, yes. In fact, the deeper astronomers have looked, the more they have found that the answer depends partly on what exactly we mean by larger, and partly on what exactly we mean by void. That may sound like a technical escape, but it is actually important. The Boötes Void became iconic because it was one of the first giant voids dramatic enough to reshape the imagination. It was large, memorable, and clean enough as an example that it entered the shared language of cosmology. But later work on large-scale structure has identified other enormous underdense regions, including what are sometimes called supervoids. These can extend across scales even larger than the classic Boötes picture, depending on how their boundaries are measured, how their density contrast is defined, and whether astronomers treat them as one coherent structure or as several connected underdense regions. And there, quietly, the certainty begins to soften. Because in astronomy, naming the largest thing is not always as straightforward as it sounds. Some objects have crisp enough boundaries that the label feels easy. A largest planet in the solar system, a brightest nearby star, a longest river on Earth, though even that gets debated. But voids are not like that. They are fuzzy around the edges. They blend into surrounding structure. They can merge. They can overlap conceptually depending on the method used to identify them. A void is not a marble sitting on a table. It is a low-density landscape feature in a vast and evolving cosmic geography. So when people speak of the largest void ever discovered, they may mean the most famous giant void, or the best-known classic void, or the largest underdense region identified under one particular method, or the broadest supervoid candidate discussed in later surveys. That is not confusion. That is the universe being subtle. Still, the larger point remains. Boötes is probably not the final word in cosmic emptiness. And that is a wonderful thought. Not because it makes the universe darker in some simplistic way, but because it reminds us that discovery is alive. The cosmos is not finished surprising us. Even its silences continue to unfold. Part of the reason this remains open is practical. Mapping the universe is an extraordinary challenge. Galaxies are faint. Distance is hard. Some regions are easier to survey than others. Some galaxies are dim enough to be missed in shallower observations. Some structures only become obvious when enough of the sky has been charted with enough depth and enough consistency. And even when the observations exist, interpreting them takes care. Patterns must be distinguished from noise. Boundaries must be inferred. Statistical confidence must be built patiently, not assumed. There is something gentle and almost touching about that process. To discover a giant void, astronomers do not look for a glowing beacon. They look for a shortage. They look for the expected abundance of galaxies, and then they notice where that abundance falls away much more than it should. Discovery, in this case, is a matter of disciplined disappointment. You expect a crowd. You find a whisper. You keep checking, and the whisper remains. That means our ability to identify ever larger voids depends on how complete and careful our maps become. Each new generation of sky surveys deepens the picture. The cosmic web grows sharper. The dark chambers become more legible. The universe's architecture emerges more clearly from the data. And with each improvement, it becomes possible to notice structures that were once too large, too diffuse, or too subtle to classify confidently. So yes, there may be larger voids still waiting. Some may already be partly known, though still debated in shape or significance. Some may be sitting in the data like faint outlines, waiting for future astronomers to recognize that a scattered pattern of underdensity is really one broader chamber than anyone first assumed. And some may simply lie in portions of the cosmic map that have not yet been stitched together clearly enough to reveal the full scale of what is there. But there is another side to the answer too, and it matters just as much. The universe is not a place where anything can be any size. That is worth saying slowly. Yes, larger voids may still be out there. Yes, the title of largest discovered can shift as knowledge deepens. But that does not mean the standard picture of cosmology expects emptiness without limit. The same early conditions that seeded galaxies and filaments also shape the typical scales of the structures that later emerge. The universe began with tiny fluctuations, and those fluctuations were not arbitrary in every possible way. They had a pattern, a statistical character, a distribution that set the stage for how matter would clump and how underdense regions would grow. So the largest structures in the universe are not unlimited fantasies. They arise from real physical history. That means voids, even enormous ones, are part of a lawful story. They are dramatic, but not lawless. Strange, but not magic. Their existence reflects the deep properties of the early universe, the behavior of gravity, the role of dark matter, and the long expansion of space itself. Even their grandeur has rules behind it. This may sound like a restraint on wonder, but I think it does the opposite. It makes the wonder cleaner. Because the universe is not amazing merely because it can be arbitrarily bizarre. It is amazing because simple laws, working patiently over immense time, can create structures so hauntingly large that they feel almost dreamlike. The voids are not miracles in the sense of breaking the rules. They are miracles in the sense of showing what the rules, given enough time, are capable of producing. And that includes the possibility of still larger emptinesses than the ones that first shocked us. There is also a more philosophical layer to the question. When we ask whether even larger voids remain undiscovered, we are really asking something deeper about the status of our knowledge. Are we near the end of one cosmic mystery, or still near the beginning? Have we already seen the main shape of the map, or are there still major features waiting beyond the edge of our current confidence? Astronomy's answer, over and over again, has been humbling. Every time we think the basic picture is complete, the details deepen, the map sharpens, the categories become more nuanced. What seemed simple becomes rich. What seemed settled becomes more precise. This does not mean everything is uncertain. Many things are known very well. But it does mean that the largest scales of the universe continue to invite caution. especially when the subject is not bright objects but gigantic regions defined by absence. Absence is harder to finish understanding. Presence announces itself. Absence must be inferred. And this is why I think giant voids carry a special kind of mystery. They are not hidden because they are small. They are hidden because they are too large and too empty to be obvious all at once. You do not stumble upon them the way you stumble upon a comet or a new bright star. You uncover them by building a view so broad that the lack of structure becomes visible as structure. That is one of the most elegant ideas in science. A thing can be discovered not by its brightness, but by the consistency of its silence. Perhaps that is why the possibility of larger undiscovered voids feels so compelling. It suggests that the universe may still contain silences broader than any we have properly named. Regions where the cosmic web relaxes into even wider chambers. Places where the nearest bright structure lies at a distance so great that the whole surrounding sky would feel altered by it. And if such places exist, or if broader underdense regions are eventually mapped more clearly, they would do more than add another record to a list. They would deepen the same lessons the Boötes Void already began to teach us. They would remind us that the universe is even more spacious than our first discoveries suggested. They would sharpen our understanding of how matter flowed into filaments and clusters. They would help test our models of structure formation, gravity, and cosmic expansion. And emotionally, they would widen the imagination again. That may be the part one finds most beautiful. Because each time astronomy reveals a larger scale than we had comfortably held before, the effect is not just informational. It is emotional. Our inner picture of reality stretches. The universe becomes more architectural, more patient, more difficult to reduce to the bright and familiar things. We begin to understand that stars and galaxies, magnificent as they are, occupy only a fraction of the cosmic story. The larger drama includes vast intervals of relative quiet, and those intervals are not empty of meaning. They are full of it. There is another important truth here too. Even if astronomers were to discover a void far larger than Boötes tomorrow, the Boötes Void would not become unimportant. That is not how science works. The first famous giant void would still matter because it changed the mental picture. It became the doorway. It helped generations of people, scientists and non-scientists alike, feel what a cosmic void really means. Some discoveries remain iconic not because later discoveries are smaller, but because they opened the imagination in the first place. The first deep field image did not stop mattering because deeper ones were later taken. The first exoplanet did not stop mattering because more were later found. The first giant void that truly entered the public consciousness would still keep its place in the story, because it taught us how to think about absence on a new scale. So perhaps the best way to ask the question is not, will Boötes remain forever the biggest? Perhaps the better question is this. How much larger and lonelier can the universe still prove to be? That question feels different, more open, less like a contest, more like an invitation. And the answer, for now, is that the universe may still have room to surprise us. Room. That is the right word for all of this. Not only because voids are spacious, but because they reveal something profound about reality itself. The universe does not only make things. It makes room between things. It does not only gather matter into stars and galaxies. It also stretches out the distances between those gatherings until the emptiness becomes one of the main facts of existence. Reality is not a packed shelf. It is a wide landscape with islands of brilliance scattered through immense open intervals. That is not a flaw. It is the design. And once you see that, the whole story of the largest void becomes gentler and deeper at the same time. What began as a simple question, what is the largest void ever discovered in space, becomes something much more interesting. It becomes a meditation on how science discovers absence. On how the universe grows structure through inequality. On how quiet places can preserve the cleanest clues. on how our own galaxy, our own stars, our own existence, depend on being in one of the places where matter gathered rather than drained away. And it becomes a reminder that even the emptiest regions are not meaningless. They teach us scale. They teach us humility. They teach us that most of the universe, by volume, is spacious rather than crowded. They teach us that light is precious because it is surrounded by so much darkness. And they teach us that the map of the cosmos is still a living map, not a finished monument. That may be the most satisfying place to end. Not with a final answer carved in stone, but with a calm and honest truth. The Boötes Void remains one of the most famous giant voids ever discovered, an icon of cosmic emptiness, a place so vast and underfilled that it permanently changed how we imagine the universe. But it may not be the final or absolute largest empty region our species will ever identify. The universe is still being charted. The definitions are subtle. The structures are fuzzy. And the darkness, even now, may contain broader silences than any we have fully named. That is not uncertainty in a disappointing sense. That is mystery in its healthiest form. The kind that keeps science awake. The kind that keeps the imagination open. The kind that reminds us that reality is always a little larger than the version of it we held yesterday. And maybe that is the gentlest final lesson of all. The universe does not rush to reveal itself. It allows us glimpses. A deeper map here. A larger silence there. A pattern slowly emerging from what once looked like formless dark. We learn a little more, and the cosmos grows even wider in the mind. We name a void, and in naming it, we realize that the darkness around the name may go on much farther than we yet know. If this slow journey through the largest empty places in the universe helped you unwind tonight, you can leave a quiet like, subscribe for more calm explorations of space and science, and, if you feel like it, share where you're listening from. It is always comforting to imagine these thoughts traveling softly through different cities, different nights, and different corners of the world, while above all of us the universe remains vast, patient, and full of both light and room. And now, as the thought of these giant silent chambers begins to drift into the background, perhaps the strangest comfort is this. Even in a universe of immense emptiness, we are not nowhere. We are in one of the bright threads. A small living world inside a galaxy, inside a web, inside a cosmos spacious enough to hold both brilliant clusters and great dark voids. And that balance, between presence and absence, may be the truest picture of reality we have. Not a universe made only of things, but a universe made of things, and the immense, beautiful room between them.